I got this code. I got this video in my recommended that I was looking at right before this, and it was like, um, it was like something like how to become an expert at programming, and it was like I don't know. It had this thing on the front of it that was like you're probably not gonna make it on the thumbnail. I just thought that was so funny. So when I was closing my tab there, I just had to think about that. It's hilarious, fucking hilarious, man. You're probably not gonna make it. That's a way to get clicks, I guess. That's how you get clicks. Anyway, for those of you who just joined, I was making fun of this video that just was in my recommended. That said something like it was a video that said how to become an expert at programming. That was the title, and then the thumbnail of it said in big red letters, "You're probably not gonna make it." It's like, that's so funny. And then you open up the box and he's like coding in VS Code. What's up, Ahmed? I don't want to sound like a dick, but dude, people are so fucking funny, man. If any coding grifter tells you how to, this is how to make it in programming, and they're just like, not good at themselves, and like, don't listen to any of these programmers, man, that are on the internet, because they have no clue what they're fucking talking about. I have no clue what I'm talking about either, so don't listen to me. But like, I don't pretend to. I don't like pretend to, at least, whatever. I get so many like programming videos in my recommended that are just like grifters, that are like talking about, oh, this is how you become cracked with this technology and with this technology. I'm so glad that we don't really have it in graphics programming specifically. I think that we're like naturally just like secluded from it, so I'm happy about that. But we do definitely have like the coding Jesuses on the internet that are just like, more about like making their audience feel ashamed rather than like teaching them anything, which is like really funny to me. I just pressed don't recommend channels getting infuriating. Yeah, I should press that more often, because it does fuel my hatred for the world, but what can you do? Anyway, so yesterday, what ended the stream was my power going out because of the storm. So I need to figure out what the fuck we were doing before then, because I was doing some accursed plane intersection with triangle clipping. Basically what we're doing now is we're taking in a mesh that may or may not be concave. We are figuring out if it's concave, taking the concave face, and then cutting the entire mesh based on the plane of that concave face. And then from there, we're recursively going down with the new meshes until we get to convex holes at the end. So that's basically what we're doing. It's kind of a pain in the ass, but we're working through it. So anyway, what's going on here? So this code is, okay, so let's start from the top, right? There's a lot of looping going on here. So we're starting with the triangles that we get from Blender or whatever, right? For our mesh. Okay, so we start with our triangles, and now we're just nested looping through all the triangles. We're testing triangles against triangles. Okay, so that part's simple. all we're doing is a dot test against all of the points of the second triangle, that, you know, the triangle that we're testing against. We want to test against every single point on that triangle, and then we are checking which points are dotted on which side of our face. So if you imagine a triangle that is like it's hard to explain, but a triangle that's on a face, right, and a triangle that's perpendicular to that triangle over here, we want to find which point is underneath our triangle and which point is above it, right? And to do that, we just do a dot test with the normal, right, to test what's behind our triangle versus in front of our triangle, right? And if everything is below our triangle, then we have a convex hole, right? So that's the test, right? Because if you have all of these, you know, triangles and they're all behind one another, that's the definition of a convex hole. If you have triangles that are facing one another, or points on triangles that, you know, are facing a certain triangle, then that's the definition of a concave face. So we take this triangle that is now splitting this other triangle, and we're going to find which ones are in front and which ones are behind the point. So that's what this is doing, right? What it's doing is, it says if the dot is greater than 0, then we will add it to 1, right? And this is our 3 points, and we will count the splits, right? So now we have these different cases. So if splits is 0, then we're just going to move on. So there's a couple ideas of what we can do when the splits are 0. I was thinking we just push everything onto a vector, like per triangle. We just have a per triangle vector. You know, how many things are before it and how many things are after it. I'm not really sure how we're going to do it. Oh, right, because you only want to split once recursively, right? So once we split here, what we're going to do is go down, right? But you only want to split once per thing, because you're going to split in half, you're going to get 2 meshes, and then you need the triangles for each side. So for these two, where it's like a triangle is completely behind or a triangle is completely in front, then we'll just push it onto 2 separate arrays, right? And for this triangle, and then at the end of this loop, what we'll say is, we said if split, then we're just going to break out, and if not split, then we recurse down. So that's very simple, and we're going to have 2 different vectors of points and faces that are recursively going down. Okay. So this is important. So if splits equals 0, then we will continue on. If splits equals 3 or 2, we want to say splits equals true. That's important. Okay. Once we split one triangle, then it's going to be, then that's all we need to recurse down. Okay. So the splits being 1 or 2 is where the interesting stuff happens, because this means that we have a triangle. I do the Zizek thing now. I think it's not a Zizek thing with the nose thing. I think it's more of a having a mustache problem, because I get hair that just points up into my nose, which is cursed. Anyway, so when we have 2 or 1 splits, that's the thing that's interesting, because now we have a triangle that's like this, and one's below and 2 are above, right? And now we have to do, it's called clipping the triangle. Okay, and so how to clip the triangle, we're going to take the plane that we are using to intersect the triangle, and we are going to split based on this formula that we did yesterday. So let's just read what this does to refamiliarize ourselves. So we have 2 new points, right? There are only 2 new points because any plane that intersects a triangle is only going to intersect it on 2 edges, right? If you can think about a triangle and a line going through it, it's only going to go through 2 faces at once, or two edges at once. So we are going to create 2 new points, right? So we have DA, which is the dot value of the first point, and then dB, which is the next one, right? And so what we're doing is we're going AB first, then BC, then CA, right? So that's what this is doing. Okay, and now we are saying that SK doesn't equal this. SK is simply the one that shows us if we were below or above, right? So it's just a Boolean. It's just a Boolean. In fact, let's just write it as true, right? Which is we split it or we didn't split it, right? Instead of using this dot value, which actually might change, let's use the S. Let's use this thing that's just a Boolean that says, are we above or are we below? And so if one point is below and one point is above, we need to make a point in between those two, right? And so we make a point using this formula, right? So I don't really remember this formula because we wrote it last time, right? And I copied it from somewhere, and now I have no fucking clue what it does. Okay. So we have the first point, which is K, right? And then we are subtracting the second point from the first point, and then scaling it by T, and then adding them together. So I think that this is basically it's like an interpolation thing. It's what this is. It's an interpolation thing. This is the same thing that I do in marching cubes. So nothing really new. Yeah. Okay. And DA and DB are the dot. Yeah, and that's what we calculate up here. Yeah, that's what we calculate up there. Okay, so we have our new points. We have our two new points. The tricky part now is creating the triangles. That's the only hard part. And so we were up to this point, and I was thinking about this point and looking at my screen and thinking about this point, and then the stream crashed. So, okay. So how do we do it? So we have guaranteed two new points, and it was either 2 points above and 1 below, or 2 points below and 1 above. We don't really know which one it is. We could find that out, but it doesn't really matter which one it is, because either way we're gonna split it the same way. And so if you think about this, right, there is only one way to split it, right? Either way. So on the side where there's 1 point, you're just gonna have a triangle with the two new points, right? It's that simple. On the side with the 2 points, you're gonna have two triangles, right? One, if the two original points were A and B, what you're gonna have is A, new point, and B, new point, A, right? So that is how we do it. That is how we can do it. So how do we do it though? How do we do it though? I'm trying to do it in an efficient way, right? By using the array of points rather than just doing a bunch of if statements. If this is the odd one out, then, How do I do it? No, I think you do. I'm thinking of all the ways to do it. If splits is 1, then if splits is 1, then the only odd one out is going to be SK equals true, right? And we could save the index of that. God, I'm making this so complicated. I could simply write an if statement here that says like, if splits is 1. If splits is 1, then you could just say, we could have a variable that's just like the bottom one, just like the bottom index. But then how do we know which triangle is going under and which one's going over? Yo, what's up today? I don't know what's up yet. I'm working on like mesh decomposition, so turning concave meshes into convex meshes. So I'm figuring out how to do that. Right now I'm kind of worried about the logistics of it and the speed of it, so that's what I'm trying to figure out right now. I'm trying to figure out what's the efficient way to figure out which points of triangles need to be split up without like having a bunch of if statements. So that's what I'm trying to figure out. Yeah, I think you do just need to have the splits thing, and then just like literally. Yeah, because we need to know which one's going under so that we can push them onto the right array anyway. Like you would just be like postponing it till later, the if statement. So do I need some thumbnails? You're a thumbnail designer? I'm alright. I can make thumbnails. It's just this current project, I I don't really have anything graphically ready to show off. So whenever I do get there, I'll make a new one. But yeah. If it was up to me, I wouldn't set a thumbnail at all. Like the problem with the thumbnail thing is that like when you put a thumbnail on a YouTube stream, by the way, it permanently locks you from taking the thumbnail off. Did you know that? The hypocritical comment? What do you mean? Weren't you the one who got mad when I was using light themes earlier? I literally ended the stream with this theme yesterday. Yo, what's up, Mude? This was the theme I had when the power went out. I don't know what you're talking about. Did I like your C get thing? It's pretty cool. This light theme is just killing my eyes. Yeah, I think it's alright. Yeah, I like your C get thing. I don't know much about version control since I'm kind of archaic, to be honest, with the way I do things. So if splits is 1, that means that 1 is out, and so we need to push it onto the other array. And how we do that is we use that point and the 2 other points. I think it's time to make these arrays that we were talking about. These vectors. This is gonna get messy though, I think. Of course, we could just technically do faces in the beginning and then and make a struct that just has points on the faces. Therefore, we don't have to worry about but then we have to worry about deduplicating points and things like this if we have a lot of points later. It's a toss-up, really. What theme? Oh, this is flat white. How did I find out that I could do all this? What do you mean that I could do all this? Like, did I like just like how I find out that I could do all of this, or are you talking about did I learn it? Because like, it's not like I just woke up one day and I was just like, holy shit, I can code. You know? I think I'm going to push the vertices and the faces separately because the simple fact that if I just push the faces, then later I'm going to have to deduplicate the vertices. And so doing that deduplication as I go along just seems like a way better thing to do in general. Also, you know what I'm realizing? I think okay. In terms of memory bandwidth, right? The probably the best thing would be for each hole to reference the same array of vertices. The problem, that's a tough one. That is a tough one. Should each hole have its own vertices for like cache behavior, or should the mesh just have a pool of all of the holes' vertices that they just index into? I'm not sure what would be better. I'd have to ask Mr. Ritchie himself. I told before that you didn't go coding in your studies, so how did you find out that you could just be a dev? Well, I was sitting alone in my room with nothing to do in life, and I decided I would program. Ah, shit. Oh, no, it's fine. I have tape on my screen that keeps the bugs out, so I thought it fell off. I can't decide between light theme, which my eyes are going with a normie dark theme. I go back and forth. I really enjoy light themes because of the stuff that I did on Windows XP. With that stuff you can't use a light theme, so I enjoyed that stuff a lot because of the light theme. So, okay. Let's think about this. So there's two different ways of going about this, right? So either inside of our holes, we can have the vertices. That means that that vertices will be duplicated across our holes, but they'll be contiguous in memory when we need to resolve collisions against them. Or we can just have another, these are our draw vertices. We could have another vertex thing here that is just our hole vertices. And then each hole will just index into that master array that we push onto. Give a setup tour? I don't really have a setup. I just use make files, and I have configuration, but it's not anything crazy. I don't really do a lot of configuration myself. I wonder what the best design is. Do you like your website remake? Yeah, it's cool. I like the theme a lot. I think it's cool. Fuck. I guess we don't have to commit to anything now, but I'm about to write a whole lot of code that's going to... We are going to have to refactor later. I think I'm going to give each hole its own array of vertices. I think that that's the best way. I think it's better for like cache. Because it's all the relevant vertices next to each other rather than just a massive, like if we end up loading in models that just have like an insane amount of vertices, this vector is going to be so insanely massive and you're just going to be jumping around in it. So I think just having each hole own its own vertices is better for the collision stuff that's going to happen later. Like modus operandi tinted. Yeah, it's nice. Want to see your typing speed? My typing speed isn't anything special. I probably have like 80 words per minute or something like that. Okay, back to what we were doing. So each one is going to have its own vector for it. So that's what I've decided. Okay. So if our splits are 1, then we need to find out which one is under. We can just for loop through it and get that. This has to be K. Ah! Okay, we're just going to go through this. Okay, so if SK is 1, then we need to make the face with it. We're just going to init all of these vectors. Once again, in my engine, the generic vector type, you have to initialize it with a size that gets stored on it. It's basically like precasting it, right? So our vertices that we have on our holes, I believe that they are just vec3s. What have you been talking about this Bart Simpson thing? I believe it's going to be like this. If I'm correct. Let me see, just to make sure. Our whole vertices are vec3s. So that's what I wanted to make sure. Okay. And our mesh face is just index into those. So, okay. So we want to... Well, first of all, we simply get... we're going to get A0, which is... Oh, wait a second. Yeah, we need to put it on both. So let's expand both of them by 2, right? Inside and outside vertices. Let's just call them O. Inside, outside, and we'll set inside inside 0 to equal new points 0. This is just how I'm thinking of doing it. Now, I may change it later because the winding of the points may need to be specific. That's entirely possible. But actually, yeah, it probably is. If outside is always positive, then you... Then you probably want these in the opposite direction. It's definitely in the opposite direction, but I don't know which is which. I read a study and decided... What do you mean a study? A study that it makes you smarter? What? So now we're gonna make the face with those two. Right. So we're gonna make an inside face. This is inside, right? No. This is outside. This is outside. It's confusing, but this is outside. Indices 0 is going to be the original in thing that was there. So that's going to be TB indices K dot pos. This right here. Poise. Don't worry about it. Assigning to size T. Oh, yeah. Oh, wait a second. Yeah, I need to push this index these all of the points actually need to get pushed onto either inside vertices or outside vertices. So if splits are 1, then we need to always push that. Oh no, this is outside. Okay, so then we just need to put. Yeah, we need to do this again actually. We need to expand outside by 1, and then outside equals point TB indices. Okay. Dot pause. And then we use the index of this to go into indices. Just to make this super clear, because this is confusing, I'm just going to say outside vertices dot count minus 1 is going to be our A0, and then we'll have the new points have their own indices. But they need to have it on the outside array. Okay. I'm just thinking of a good way of doing this. Why am I on Windows? Because this computer sucks, and I need very specific NVIDIA drivers that I can only get on Windows for it to run well. A lot of my projects were written optimized, but they ran like shit on Linux because Linux has shit drivers. Yeah, I have a take that's like, people on Linux just, usually use good computers and then don't see a performance problem. Especially with NVIDIA. I have to use very specific notebook drivers for this computer because it's a Windows computer. So Windows laptop. So maybe one day when I get a good computer, then it'll be different, but yeah. Okay, so this is the interesting thing, right? So I0 can always inherit the normal from our original normal. So that's good, that's good. That is good. Is there a way for me to do this without this? This is kind of complicated for no reason. Yeah, let's not worry about it. Let's not worry about it. I'm just gonna do it the most simple way because it's already fucking super complicated. Like, the logic for this is going to get stupidly complicated if I try to do it in an efficient way, so just so that I can get it done right now, I'm just going to do it this way, and maybe later somebody can be like, hey, dustmite, why didn't you do it, you know, the not stupid way? But yeah. Actually, yeah, why am I doing this down here? I can just do that. I hate the nesting too. Trust me, I hate the nesting too. It sucks. So what's gonna end up happening is I'm just gonna shove this in a different function anyway, but right now I'm just building it out in this function. Okay. The reason why I have to do this if statement here is because the second inside triangle needs to obviously have different indices than the first one, so that's very true. And there's also, like, you know, there's possibly like you know, I should have made it return a value here so that I could, you know, have these indices already, but honestly, I you know, I don't regret it that much because so far it's turned out fine for me. So if optry emitted equals 0, we need to make the first inside triangle right, yeah, and k stays the same. Why'd I call this AB instead of OA? Okay, so we put it on the vertices. The worst part about this is that we are going to have duplicated vertices inside of the thing. This doesn't automatically deduplicate vertices is what I'm kind of realizing. And you probably need to do so later, which does suck. Hop on Fortnite. I've never played Fortnite. Also, this should be O, obviously. I have no clue how we're gonna deduplicate the vertices. I think we just have to like do a hash table to do it. Okay, so the first one can be IA. If we're gonna do the first triangle, then let's try and think about this, right? As like, if the first triangle is outside, then that's a triangle upwards, and we made it with which one is first? I guess it depends on the winding of the triangle, but if the winding of the triangle is counterclockwise, then but it could be going the other way around. Well, then there's really no guarantee about winding, is there? There is no guarantee about winding. Well, then I have no clue. Use NixOS? Yeah. I know. I do know. Okay, so there's no guarantee about winding. Well, also let's make sure that we don't have this uh, inside issue there. Yeah, there's no guarantee about winding, so I shouldn't even really worry about it. Kind of sucks though. And here we're gonna do the same thing. Well, if the first one has 2 outer, then we will push, instead of pushing this one only, we need to actually store this one separately. So we need to store IA outside, and then this will be, and then we'll use IA ID. And is it IB or IC that we will go with? I think it's IC. Well, it would be this winding. Ooh, how do I figure that out? Well, technically, it's whichever one is closer to ID in this case. Technically, so we could figure that out. You should do web dev in JS. Why? Why? I feel like that sounds like torture to me. Let's just do this. If now I have to figure out how to get these vertices, huh? Let's just use new points. Okay, don't ask me what I just wrote in terms of code. I'm gonna like Men in Black fucking make you guys forget about this. That's just the way it goes. That's just the way it is. You know what I mean? What did I just write in terms of code? In terms of like, to give you like an example of like what it's like, you know, I think it's like, you know, just like an insane amount of like war criminal stuff, you know? The problem is that now we have to write splits equals 2. And it's just the same thing. Yeah, there's definitely a better way to write this. Hold on. If splits is 1, then we could simply swap the pointers to the outside and inside vertices thing. Would that just work out of the box? I think it might. Also, this is obviously inside. It's not. I think that's what I'm gonna do. I think I'm just gonna swap the pointers. Let's go. This is certainly one way to do it. Some great programmers are probably turning in their grave though right now. Okay. So what we just wrote is splits equals 1. So if splits is 2, then we'll simply swap the pointers. Hold on, is that going to work? Wait, no, I don't. I have an idea. You just do this. You just do the same thing. Wait, but then no, this is fine because it used two of the new points. Okay. The first one we emit will always use 2 of the new points so that if we don't have another one, then we're still fine. What do I think of Golang? It's just another language that just doesn't have a point, but I guess it's fine. I don't really see like, you know, a real point in you know, like I've tried other languages. It's just like, other than C and C++, like I just don't really understand why we would do anything else. Yeah, like it's just, and it doesn't it Go have a garbage collector? That's just crazy to me. Like, what's the point of making a language like Go and then giving it a garbage collector? Like, wow, you just made me like hate it even more. Like, okay, we could have deduplicated a bunch of code here if we just swapped the pointers based on the iteration. But we're just going to ignore that and be lazy. That's what we're going to do. Okay, that's a lot of code that I have no clue how to debug. Oh shit. Oh no. Oh no. Oh no. Oh no. Shit. That's just how it is. That's just the way it goes, or whatever the fuck the song is. Okay, so if there are 0 splits, then everything is inside. I think I may have the inside and outside backwards, by the way. Hold on a second. Yeah. Yeah, I'm right. I'm right. I'm right. But my idea of inside and outside might be swapped. No, I think outside should be. Yeah. Outside is a weird way of putting it, but outside should technically be. Oh, wait a second. I have to use OA here. I almost missed this. That would have been a disaster, to be honest. Okay. Okay. So if there are no splits, then we're all inside. Then we just add everything to inside. We just add all the vertices to inside. What would have happened if you picked up Python instead of C? I would have never picked up Python instead of C, because when I started programming seriously, which was like 2-3 years ago, I was at a point in my life where I kind of realized, what the what the you know I kind of like grew up like mentally, like when I was like younger, like at the end of my teenage years, like I was definitely doing some JavaScript and Python stuff just because that's what everybody was doing, but I never really enjoyed it because you can't write fast Python. It doesn't let you optimize because it's garbage collected and bullshit, Like, it doesn't want you to write good code. That's the problem with the language. Same thing with, you know, a bunch of different languages, So I don't know. There's no world in which I just happen to do Python instead. It just like disagrees with my character, which is that I don't like things that are made poorly. I just like go outside and I go to the grocery store and everything is just slop bullshit. I go to the movies and I watch these new movies coming out and it's just slop dog shit. Like, I don't know. There's got to be something else, man. There's got to be something else. And that's why I write C, man. That's because it's like it allows you to write good code like all the time. It's like, it's just like write good code. It wants you to write good code. So that's my gripe with a lot of modern like abstracted languages. I don't think it makes people write good code. Anyway. Instead of just going in a loop, we can just expand it once and then um, and inside verts are going to be uh, oh, actually, yeah, this can't actually be this. This has to be how many times have you been told to unironically stop coding C? I've been told that about as many times as people have told me to use AI. So, a lot. It's surprising the people that have come on here and like told me use AI. It's like, I don't know, like how like stupid are you? Like, it's just so insane to me, the world that we're living in. But yeah. Oh, also this normal isn't the normal of this triangle. It's the normal of our initial triangle. Oh. Whoops. Whoops. Then I need to change some things. But I mean, the people that tell me to write C++ aren't necessarily wrong. Like, there's a lot of like serious advantages to C++. I just don't like C++ because of, I don't know. There's a lot of like generalizations that are made in C++, especially in the standard library, that like, like with std vector and std sort and things like this, that yeah, sure, in a lot of cases they're optimized to make things as fast as possible, but depending on your use case, those things just might not, you know, be as efficient in terms of memory and things as you would want. And when you're in C, you know the exact, complexity of all of the code that you write, you know? And I that's the part of it that I love is like I know all the time how shit the code I'm writing is. Like because it's so simple. Dig doesn't sound that bad. I should try it out once I learn Haskell. No, it sounds awful. Zig is like the worst out of it, right? Like Rust definitely has its merits, but Zig is awful. Zig is fucking terrible. And the guy who made it is such a tool. I don't know, man. It's just it really just is not great. Not great. What did the guy who made Zig do? I don't know. It's just I heard him like talk, like do an interview once, and I was like, oh my god, this guy is fucking insufferable. I don't know, just he just the people that do Zig are kind of like finance bros. I feel like that's the vibe I get from it. It's like an NFT language. That's how I feel about it. Maybe I'm wrong, but back when I was gonna learn like Rust, I was looking at like modern languages that I could like dip my feet in or whatever, and one of them was Zig, and I just looked at it and I was like, wow, this is some fucking Zoomer nonsense. This River Window Manager, what is that? Also, just because something is made in a language doesn't mean that the language is good. That's like such a bad metric. There are so many good things made in shit languages. You know? That's all, every programmer can make something great. There's so many programmers coding in so many different languages. I've seen so many people write amazing things in JavaScript, for example. That doesn't mean JavaScript is a good language. But for the same reason, it's also they write shit that's slow in those languages too. Just because it works okay doesn't mean that it's like written well, So just because it's a good program doesn't mean it's written well. Isn't the user base of a language a bad metric as well? I guess so. I guess you could make that argument, sure. But like I don't know. Maybe it is, but I think I have some extra annoyance with it just because of just the amount of people that I've gotten that have told me that I should do Zig or whatever because it's the hot new thing, even though it just compiles worse. It's like I don't know. I've got a real kind of that's like one of the things that I'm really have a strong stance on is things being made well, in terms of the world. Everything feels so vibe coded nonsense nowadays that it's so I have a strong stance on it because of that, and because young people have told me that there's no use for a language that literally is just the same thing as their language. I don't know. It's it's just ridiculous. Anyway, I think that this is pretty much the code. We just have to figure out a way to recursively split this and not break the computer. That's going to be the hard thing. This whole thing is going to be the recursive split part. The problem is this TB indices and the the original indices go into mesh tries and mesh vertices rather than actual vec3s. So I have two options. I can either rewrite this up here. This will just be the top level function, and then it'll just call the recursive part up here. Or I could have it copy these mesh faces and vec3s into a different buffer, and then just move this up here, into a recursive thing anyway. Those are the two options I have. But I'm not sure what I'm going to choose. I kind of hate the fact that I would be copying and pasting 200 lines of code. Like, that's not very fun. But it might be what I... Like, it's the more efficient way, because the only other option would be to literally copy these points into a buffer of vec3s, because this internally has to use vec3s and not those. So the only time we use it is here to get these pause, because it goes off the original array. Let's figure out how we're going to do it, though. So we have these inside vertices, inside faces, outside vertices, outside faces, right? The outside vertices and the outside faces are going to be the only ones that we split off with, right? And then we recursively go, right? The inside one goes with the inside vertices and the inside faces. And then the outside one goes with the outside ones. And then as we go along, we make holes as we continue downwards. The thing is, we should only be making holes at the bottom of the recursion. So I think I'm just going to write that here then, where else we make a hole, because if there isn't a split, then we are at the bottom. Did Mac DeMarco give me my family back? What is that reference? What is that reference? So we'll just push it onto the vector for the mesh. So it'll just go mesh holes, and then we'll just expand. Make a new hole, and then we will on the hole, the vertices will equal our inside vertices, and our faces, well, actually our faces, we don't want to have faces, because we're going to run incremental hole on this anyway. From the black hole between his front teeth, right? Yeah. Fortunately, I think my family is safe. We could compute the AABB. I don't know if we have a function that does that yet. But anyway, let's free inside faces then. And let's just leave inside vertices, of course, because we just copied that buffer. Well, we didn't copy the buffer, we copied the pointer. That's the whole point. So if we didn't split, we make the hole. Copy the vertices. Do I have a compute AABB from points? Oh shit. No way. Wait. That's the best part about having like a big project, you know? You get to a point where you can just like type in, "Hey, do I have this?" and then it just comes up. It's pretty sick. Like with the game engine, that was the most like, fun part about the game engine is like I just got to a point where I just like literally had just like, you know, like 40,000 lines that I could just search any formula in. I hope that we're gonna get to that point again because that was a lot of fun. Okay. Um, Calculate ABB extents. And now we are ready to run incremental hull on this hull, and then calculate the BVH afterwards. So that's what this is all going towards. Okay. Down here, what is the point of this? Okay, yeah, this is just old code. That was our little outline. And if we don't split, then we want to call whatever this function is again. But we have to figure out how to structure it. Also, there is going to be like possible memory problems here. Because of all of the vectors we'll be making on the way down. So we have no way of knowing what's gonna happen. Alright, so what are we gonna do? What are we gonna do? Well, we actually will need the mesh for pushing the hole at the end if it doesn't split. We're gonna take in points. We're gonna call it vertices. Vertices and faces. That's necessary. And we're gonna have a depth, and that will tell us when, 8 recursions down, I don't know, I probably will call it, because that starts to get to the point where there's a scary amount of, because you got to realize when we were recursing, we're creating new vectors every time with copies of the points, and all of those are going to live in RAM at the same time because of recursion. So something that people don't usually think about when they're writing programs, to be honest, with recursion, but that's very important. Okay. So I think that we're just going to copy all of the code basically into here. Which sucks. I wish that there was a different way of doing it, but I think that this is the way. Actually, you know what? I don't think so. I don't think so. I don't think so. I don't think that's what I'm going to do. I think I'm just going to copy the vertices vector into another buffer and then go from there. I don't want to like copy all of this code in case I need to debug it. I don't want to have to do that. Helium browser? Yeah, I don't know what Helium browser is. I tried to get like different browsers a long time ago because I don't like Firefox, but it never worked out. I tried like Ladybird or whatever. All those like alternative browsers just run like shit on my computer, so I can't do it. Okay. So now we'll just move this into there, and we'll just pass in decompose whole with with the mesh. Yeah. Oh, I have it as a vector pointer vector. Okay, well that's fine. I'll just set it to a vector then. Even though it's not. Okay. Okay, so now we have successfully copied the points into vec3s so that we can pass it into the recursive function. And then we free the buffer after, of course. And then in the recursive function, we will simply iterate through the vectors that we pass into it in this exact code. So we just have to copy that into that function. And we will resolve the 17 errors with the naming stuff that we have to do. Let us get... So obviously we aren't going to be using the mesh tries. We're going to be using the faces. Faces count. Yeah. We're going to need a... let's just straight up copy the cast that we do here over here. We have to dereference the pointer, which is actually kind of scary to do this in recursion like that, like what I'm doing right now. Not something you really want to do, but I trust myself to write code. Okay, so instead of using dot pause, we're not going to use it anymore. I'm considering using points rather than point. It just seems better for understanding the code. So that's what I'm going to do. And we're not using pause anymore because we're using vec3s and not the point struct that has rendering data on it, like vertex based color and things like this, right? So instead of doing any of that, we're just using raw vec3s now, because that's what we're going to be storing in our collision holes. I've been working on a blog post that I will be putting on my website soon, detailing the whole collision system, including the mesh decomposition that you're seeing right now. Once I get the mesh decomposition working, but yeah, I have written a bit of it. It goes from just making incremental hole through GJK and through EPA, which is what I've been doing the past few days. There are quite a few good resources, because I know that this stuff can be a bit intimidating, I guess. And once again, the recursion thing, we're going to go depth +1 so that we can count upwards to see when we bottom out. Okay. Have I tried Ladybird browser? I literally just said that I did. I said that I tried it, yeah. And it ran like shit. So it ran actually like so terribly that it was like impressive. I couldn't barely like load a web page. It was insane. Maybe I used it wrong, or maybe my computer is not, my computer isn't good. So, but I think my computer not being good is a good thing, because it makes me write good code, right? You want to do this? Ah, fuck. Yeah, you're number one. You are. Ah, shit. Okay, so I'm thinking how we're going to do this. So we're going to loop through all the faces, and then we check against every face if that one's a concave face. And if so, then we split on the concave face. And per face, we're going to split into two halves, into inside and outside. Right, no, but we go through all of this and always split into inside and outside, yeah. The important thing here is to always free all of the buffers. That's very important. Oh, but hold on a second. But we're using the buffers when we go down and recurse. No, I think it's fine. I think it's actually fine. I'm really hungry. Yeah, I cannot give the food through the internet, unfortunately. Unless you can make that happen. So the thing is, we give this inside vertices at the bottom, so we can't free that in that case. Oh wait, this is supposed to be if split. And then this is if not split. At the end it should be if not split. Hold on. This is confusing. Memory safety, memory safety, memory safety, memory safety. The thing is, if there's... If there's never any split, then we make the whole. I think we just set whole vertices to the vertices, though. The problem with setting it to the vertices is that we later free those vertices from the parent when we exit recursion. So we can copy that vector. We can copy the vector. I think that's what we should do because it's kind of complicated. Like if we give our parent our vertice, or our child our vertices, and the inside and outside faces. The fastest way would be to actually keep track of if our children is done. What's the font I recommended you again? Trident 8x16. MX437. Ah, shit. I mean, that's the most fancy way of going down. Yeah, I might do that. You could send a pointer down to the child, and then the child communicates to the parent, hey, I need you to not free this buffer for me, please, because I'm keeping it. Thank you. Because otherwise it needs to be destroyed. Huh. Okay, we could try it. We could try it. What are we gonna call it though? A bool pointer child? And then if we didn't split, then we set and therefore we just set this to this buffer, and then we just don't free it here. Leg x-ray? Why is that? Do you have pain in your leg or something? Were you in like a car accident? This is confusing. Okay, so basically what's happening here, right? What's happening here is that we have a pointer to a flag that we're passing down that tells the parent if it should free the buffer or not. Because if it frees the buffer that we are setting to our vertices, then that's a big problem. Then that's a massive problem. Actually, so we don't actually care about the inside faces. We're just going to free them anyway, because the faces don't matter. It's just the vertices that we use. The vertices are what we use here, and otherwise we can just free the faces. If not has leaf, then we free that. Every morning, especially today, my left leg is just in agonizing pain, especially when I try walking. It gets better in the evening after it gets walked off. Oh shit, that sucks. That really sucks. So did you hit it or something? Or is it just like, shit, my leg is broken? Or like, damn, that sucks. That does indeed suck. Sorry for your leg. Um, so I've been talking the whole time and I didn't really realize, but I think the code is finished. If I did it right. I have no clue if I did it right. But... we want to, of course, exit out if the depth gets too high. I'm gonna have a max depth of 6. How do we gracefully exit out? Here. It's like this. Okay, so how do I... how do I do this? Okay, so I wrote the function here. Mesh decomposition. So we can call mesh decomposition and not do incremental hole yet. Oh, I need to put it in the header. What the fuck is wrong with me? That's the whole reason I copied it, and now I just fucked it up. It's alright. It doesn't sound alright. It sounds like your leg is in agonizing pain. Like, that doesn't sound alright to me. Like, personally. That does sound like pretty terrible. Sorry, it just got stuck in my head. Okay. We have mesh decomposition. Okay, so how are we testing this? How are we going to test this? Let's decompose mesh 2, which is the one with the fucked up ground. And then let's try and render the bounding boxes of said thing. AABB to vertices, is that what it is? I think that is it. AABB to vertices? Yeah, I do this. Instead I use BVH nodes though. Okay, so instead of using BVH nodes, what we'll do is we will should really make... Alright, let's do this. You're up for 16 hours straight. Jeez. Damn. I've always been really good at taking pills. I don't know why. I hope you get better. You seem to be going through some shit, I guess. I'm not gonna really build any whatchamacall abstractions right now. I'm just gonna do this. Big girl, I could do it. Yeah, I mean, that does sound rough though. Oh yeah, I was just drawing arrays for these. Maybe I should just do that. This just does vec 3s though, so we have to turn on the wireframe thing again. And then just have it not do whatever it's doing here. And instead render AABB. And this is going to be m2.AABB. It's a pointer. And the VBO of wireframe VBO with an offset of 0. Let's see if this goes. Setting up impermanence. Yeah, sure. I hope that you get this X-ray though, because that does sound. Okay, we immediately crashed. Okay, here's something. Do we still crash if we just go back to rendering our good old thing? I just want to see which thing we're crashing on. If it's okay, we may be cooked. Just a little bit cooked. Okay. So let's not call mesh decomposition. Okay, so now we see the AABB of the full thing. Okay, so what is happening here? Okay, so every time we get down here, I want to print depth just to see if we're going somewhere. Okay, so we do get to max depth, which is probably not a good sign. Not gonna lie. A 74 config files? Yeah, that's a lot. That is a lot. I think if I put this into GDB, it's not going to tell me anything. But we can try. So segfault on points TB indices. Points TB indices. So it's either on TB indices or points. Okay. Okay. So we probably free something that we're using later. NixOS mentioned, yeah. Or I'm not. Oh, hold on a second. Oh no, I do only add one vertex every time here and one face, so it can't be that. I think points TB indices K 65, so right at the top. Hold on a second. Oh, I never wrote the thing that, oh no, I did. No, I did write this stuff so that if the splits are 0 or the splits are 3, then they go into there. So that's possible. That's fine. Oh. No. Because we go through every other phase for this phase. Oh, wait a second. I didn't change this to mesh or to faces count. There we go. That's what it is. I just had a typo. No type size for vector specified. Oh. And why is that? No type size for vector specified. Okay, let's GDB that. That's my own error, by the way. Decompose whole. When I set whole vertices to vertices, I'm guessing that dereferencing that pointer isn't good. That pointer isn't good anymore. Setting that whole vertices is at the end. It gets set to this. But I set this leaf to true. So that would have to mean that these inside vertices are dead by the time that they get there. I want to test something. I'm going to assume that it's this exit and not the other exit. I don't know why that would matter though. I want to see what this pointer is. No type size for vector specified. Oh, I don't initialize mesh holes as a vector. Okay. Not C. I never initialized the vector. I'm so stupid. Depth 32. Okay, I feel like we gotta exit out of this. Depth 32. Oh, I don't have a return here. Whoops. It shouldn't be splitting that far, though. Okay, something is definitely wrong. Something is definitely wrong. Why do we keep on exiting out with the exact same pointer? It's strange. Like, that's the exact same pointer, right, every time. That shouldn't be the case. No, it's fine, it's fine. I'm stupid. Okay, okay. I think that this is completely going bad, but whatever. By the way, this is supposed to, we're supposed to be doing the render ABB. We were supposed to be doing this for each hole, so okay, so that should render the holes, but I mean, oh, we don't break out here. We're supposed to break there, I think. Okay. So these are the bounding boxes that we split us into. Okay. Let's draw the mesh underneath. How do I do that? I want to just display the thing on the screen, but I forgot. I hard-coded something to draw a mesh earlier. Yeah, I did this. Can I just do this with... Yeah, let's just do this with mesh 2. Just so that we can have a visual of where the mesh has decomposed. Okay. We are rendering nothing. Hold on. The fuck? I mean, I didn't upload it, but okay, that's confusing me. What's my goal for the stream? I'm trying to, right now what I'm doing is I've set up mesh decomposition. So basically we take in a concave mesh and we're splitting it into convex meshes. And then we're going to wrap our BVH builder around it. So that's what we're doing. And I think we're decomposing properly. The problem is that I'm trying to visualize it right now so that I know that I did it right. What the fuck did I just do? Because whatever I did is, it's causing us not to draw anything. Whatever I just did, we need to undo it so that we can draw to the screen. What the fuck did I just do? Oh. Oh. That's what I did. Oh, my bad. I'm so dumb. Sorry. I was so confused. We can go back to what we were doing here. Oops. I put the pointer to 2 instead of the thing. Okay, but this isn't actually showing us anything. Hold on. Let me try and figure out what we're doing here. We are going through M tries. Try points P. No, not try points P. Oh, we're casting this to the wrong. Triangles M tries dot buffer. This isn't. Oh yeah. So this is actually a mesh face. I changed this type, but I didn't obviously this is old code, so that's why. And so that's why this isn't going into points. This actually goes into the vertex buffer. I need to create an abstraction over this, but that's gonna happen in a bit. I want to make sure that I get this right. Actually, this is point. Okay. And this needs to go to V. And if I'm reading it correctly, that should be just fine. Okay, there we go. Okay, so let's see where we decomposed. So this part got separate. And this part got separate. So we didn't do it correctly. Definitely not. What we should see is a box around this, I believe. Because this is the face that's sticking out. Instead we have a box that just doesn't include it on its own. What worries me is that we hit the bottom every time. If we increase the, well, maybe we didn't actually hit the bottom. If we increase the depth, then this should take a while. But maybe it'll See, yeah, this is the problem. This isn't getting its own face. Yeah. Also, the way I'm visualizing this is kind of weird, so that's also something to keep in mind. But yeah, we should be splitting here, like all the way across. All right, so let's try some things out. So let's try just flipping this sign. That's gonna be the first thing we can try. And nothing changes. We have more things down here, but nothing really changes. I need to make sure that I'm not using TA indices anywhere inside of the middle section, because TA is the outer triangle. I knew that this was going to be a pain to debug, but okay. I thought that flipping the sign would do something, but just looking to see if there's any bug that I made when I was copying things around here. Remember, these indices that we make here are only relevant to the vertices that are in the current array. Oh, maybe I'm supposed to push these onto the... Oh. I didn't consider that. I did not consider that. Okay, maybe I need to push this onto one of the buffers, the original face. But the question is, which one does it go on, inside or outside? Hi, Lily. Hi, Lily. Do I go inside or outside? I think inside. Okay, so let's just make sure that we put this on it. So, um, there's kind of no way for me to like debug this shit. So, yeah. Oh no, I can just go TA. Oh wait, no, I can't go TA because TA is no. I need inside faces. All right, let's try this. I didn't put the original face inside of the original thing. So that's okay. So this gets a bit longer now, or I mean wider, but it's still something I'm interested in is that we seem to have duplicate holes, right? Or maybe not. Maybe that's just yeah. Oh no, we do. We seem to have duplicate holes. Like look at how it's split up. It's like hmm. If split we break. Maybe I need to give it high. I mean depth 6 seems crazy to me. That should never be a thing. Yeah, like we're just getting further and further down. There's probably something stupid that I'm not thinking about here. Hmm. You like my glasses? Thank you. I appreciate that. I don't know. When I went to the glasses store last time to get glasses, it was like they were pressuring me into fucking choosing shit, and I was taking forever. And so I was like, damn, I feel bad, but also I feel like it's a big decision, you know. It's a big fucking decision to make. Why does changing this not change anything? Like changing the side should definitely change a lot of shit. Like it changes some things. Okay, no, it changes a lot. It does. Like that gives me like a bit of confidence that things are correct. Hmm. There are some things that are like, why is this split though? Like here, like it doesn't make sense why that would be a split hole. I don't know. It may be like some floating point imprecision stuff. Or maybe I just made a mistake somewhere, I'm not sure. Maybe with the winding somehow. But the normal of the triangles stays the same, so I named these I0. I don't think it matters, but we should just use this naming convention just for clarity. Yeah, I don't think it should matter since the normals get passed down. I don't think that it would matter. I'd like to see the triangles that we get out afterwards, uh, but it's kind of hard to do so. I would have to cache them on the the holes themselves, which we would have to undo later. So maybe I just try a little epsilon and see if that helps us out any more. The weird thing is that there's kind of two holes on top of themselves, which is annoying. If I had to guess, I'd say that probably because of this depth check, we are... I mean, this might just get stuck in infinite recursion, though. Yeah, now my computer's fucked. Yeah, I did consider that. So maybe this is a logical error then. It's calculate ABB from points. It takes in a vec3, right? All of our stuff is vec3, so should be fine. I have a feeling that we're splitting in every single triangle. Like I bet if I write this out, I doubt that we ever hit that. Hit a natural split? I doubt it. Oh, we do. We hit only a very few. Only very few. Very, very few. I wonder if it's a point with if it's a problem with point duplication. We have a function that actually deduplicates points, so we could just do that. It is brute force, so that is something to keep in mind, that it will be slow. But I did create it earlier. It was called decompose, even though it was supposed to be the very naive decomposition. But we can just move it up here and make it so that it takes in just a vec3 pointer. Yeah, let's just take in a vector pointer verts, and let's just copy the code. It's very simple. Let's call it deduplicate. Let's make it very naive. Let's just take in a inverts And we'll have outverts, and just because I don't want to fuck up the other one. Feel more productive or less productive? I think when I started, I was definitely less productive. It depends. Like, if I get really stuck on something, like, in terms of, like, I have no clue what to do, it's really, really, just taxing to be able to do that, like, while talking it through and, you know, dealing with people's eyes on you, you know? Like, that's really difficult. Like, when I get stuck, it's really hard. But other than that, I feel like it makes me pretty productive because I, you know, I can't really, like, look away, you know? I'm usually somebody that does just, like, stay locked in most of the time anyway, but yeah. It's my favorite thing that computers do. I have no clue. I think registers are pretty cool. Like, writing simd is a lot of fun. That's probably, like, the most fun thing that I've enjoyed coding is writing a lot of simd. Just personally speaking. We don't want to be going by outverts.count. No, we want to be going by inverts. We want to be going by outverts to check if they're equal. Let's just do that for now. I don't really know what that's supposed to fucking do. If unique, then we add it to outverts. Okay. And then what we do is we simply free the inverts buffer, and then inverts equals outverts. Okay, now before we call the first whole decomposition, I want to call deduplicate with our verts and see if that does anything. Okay, we crashed. Let's see what I fucking did wrong. Yeah, this is going off of... Oh, wait, no, this is wrong. I init the vector. I'm sure that that's the right type. At point I, this is supposed to be inverts. It's supposed to be in I. Okay. Holy fucking shit. What? Okay, I may have made some mistakes. Oh, right. The faces are tied to the vertices. Yes, that sucks. Does that suck? Yes, it does. Does that suck? Yes, it does. Okay, so why didn't I just call decompose then? Oh, because it puts it in a mesh hole vertices. Oh, instead of mesh vertices. Fuck. And it doesn't fix the faces is the problem. That's the problem. Actually, this is very simple to fix. I should stop being lazy and dramatic about it. We just need to put in the mesh instead. And instead of going through the verts themselves, we're just gonna go through the faces. I want to get the shit that I have to do. Let's just get this, right? Because basically our faces, our triangles are just indexed into the points themselves. So yeah. It's gonna return a vector to the new vertices, but it's also going to have to change the but you don't want to change the tries. You don't want to change the tries directly. Fuck. The whole point is you don't want to ruin the draw buffer. You don't want to touch it. How do I do this without being stupid? We just have to have another buffer. Okay, we'll take in fuck. We'll put in both verts and tries. Yeah, and we don't have to use the mesh anymore. We'll just change both of them. And instead we'll take in the vec3 of the translated points, since we're already doing this anyway. Okay, so now we're going to be going through the faces count, and we'll just be going nested loop through this. Nested loop through it. Okay, and everything goes in the nested loop. And we'll just check out verts if it exists, and if it does exist, then we need to replace it, the index with that index, right? So previous definition is here. Where? Oh. In points. Okay. So now we're looking through the vec3. Oh yeah. I'm all over it. Okay, so that's our in point. We want to check that point against V, which is verts J. This is gonna have to become K. Oh, I don't want to be writing this right now. This is boring. So we get the outverts. We're casting the vec. We need to keep casting the vec because reasons. Because we're expanding it. Okay, so if it's equal and it's not unique, then we need to change the f indices j equals k. Otherwise, if it's unique, we need it to equal whatever that is, which is outverts dot count minus 1. Okay, there we go. And now to free at the end, we want inverts to equal outverts. We'll kill the old buffer, and the faces stay the same actually. It just changes the it just changes it internally. Okay. So to deduplicate, we will pass in verts and tries. Wait, but mesh tries can't be a thing. So we have to make a vector mesh tries. Init the vector. Type size is size of mesh face. And we will pass in mesh tries and the verts. And we will be passing in this mesh tries into here. And then we'll free the buffer at the end. I put a little squiggly. Okay. Alrighty, and we have 0 holes. We ended up with 0 holes with that. Okay. Oh, because I never copied into mesh tries the this. And we crashed. Oh, because I never mallocked it. Is 4 gigabytes to install one music player worth it? I have no clue. I feel like that is a lot though. If I had to guess, I'd say that's a lot, personally. Okay. Yeah, I'd say that there's just a lot of ones on top of each other, but overall they are kind of like following the shape properly. But I do think that there is somehow infinite recursion inside of it. Which seems frankly hilarious to me. Like if I make this 10, then it's just gonna make more. This shouldn't need 10. This should, like, what the fuck is that? Like, what is that? Like, that doesn't make any sense. Oh, I didn't put intries into here. Oh wait, no. I did put mesh tries there, yeah. I did. So we did put it into deduplicate. Now, does it do a good job of deduplicate? That remains to be seen. Goes through faces count, goes through all the points, indices J, tries I, goes through outverts, we cast it right before, goes through all the outverts, we check for equality using point against V, which is verts. What is verts? Verts is what we cast there, yeah. Okay. And then we set F indices J to K if we find the duplicate. Otherwise, we add it, and then we set F indices J to outvert count -1, which is where we put the point. We resolve the faces like that. I mean, that makes sense. That does make sense to me. Yeah, the deduplication thing was probably just like a long shot. How am I supposed to debug this? Do you think it's even possible to... Like, we calculated the bounding box from the points. Hold on a second. I think I'm realizing something. Oh. Wait, maybe not. I feel like this has to be greater than, though. Because if it's less than, then it's literally just faces that are going across. Like things like this is interesting to me because those there's no way that those are correct because that's literally just 1 point. There's not even a face in there, I think. I wonder if I just made a typo somewhere. How do I debug it? Oh, wait, hold on a second. Hold up a second. Oh. I'm adding triangles twice. So if I equals j, don't only continue, then you add it, then you add it, then you add it. And then you continue. Because you don't want to add triangles twice, and that's what I was doing. Wait, was I? That definitely looked better. Are you completely improvising the algorithms or referencing a paper? I'm kind of just improvising, to be honest. I came up with the idea based on like reading what other people have done, but the method of like decomposition is sort of very complicated actually. If you're not just like kind of doing what I'm doing, which is just kind of like having the idea for it. If you want to get into like VHACD or whatever, it's like very complex stuff. So there's no way that I'm going to do that. Like for GJK and EPA, like for sure, I basically just followed other people's stuff. But for this, it's absolutely out of the question, I think. Maybe there is some epsilon issues though. Because right here we're adding the inside vertices to both. Even though they're right on the boundary. Wait, hold on a second. Yeah, no wonder I'm gonna split forever. These points are... Maybe there is like an epsilon thing here, because these points are technically right on the edge of the plane, right? Because we're doing this plane intersection thing. So I wonder if we're grabbing the same points in the child and splitting on the same points that we split on in the parent. Is there any way that I can check this? I could check it in a really janky way. I think we should just like limit the recursion like a bunch and then just check it in a really janky way. By just printing out maybe I shouldn't have done this macro like I did, but that's neither here nor there. Let's see what the split points are. We're gonna get a lot here. Here they're the same, which is ridiculous. A couple of times they are the same. Unless we're getting 1, 0. No, we go 0, 1. Here they're the same. If they're the same, then that means that that it hits right on the side of the triangle, probably. Or it hits exactly the top point, and then you get the exact same things. Okay. We could probably just check if new points... Let's try something here. There were even triple sames. Yeah. Well, triple sames, we're only checking 2. So what a triple same would mean is that it was the child that got the same exact point. That's what that means. Which is what I suspected, but... Okay, so we only see 1, 2, 1, 2, 1, 2. Oh, no. Hold on. Yeah. Yeah, every 2 should just be garbage memory. Okay, which it is. That's exactly what I want to see. We should only see 2 points. I think what I'm going to do is I'm just going to create a check for if we get the same point, and then that's going to be just to continue, I think. Then we have to decide if we're keeping it as an inside face or an outside face. What would cause the same point though? Can we get it earlier? No, not really. Okay, we're just gonna do this. Then we'll just treat it as an inside face and then continue. So the problem with the holes overlapping is not a simple one to solve at all. The reason why they're overlapping is because holes that are over here also have points from over here. Because it sees this concave face and then it cuts through and then it gets points on the other side. So going by bounding box doesn't really actually tell us fucking anything. about the actual shape of the holes. What might give us something is to instead of just going by bounding box, to actually render the points, which we can do fairly simply by just doing the vertices themselves instead of the wireframes. And then coloring them like different colors based on which one they are. I don't know if I want to really commit to doing that just to debug right now. That would probably be kind of a pain in the ass, to be honest, now thinking about it. But yeah, that did seem to clean it up a bit. It's not, I don't really know how to test it. I could just put it through the hole finder now and then just try and see if it makes correct concave holes, but the fact that this is going off is like a really bad sign. It should exit out of recursion fairly fast, but it hits the bottom every time, which means that it's splitting way more than it should be. So like, look at this. Like, all of them overlapped like that. Oh yeah, this 012 obviously can't be that. Inside vertices dot count -3. Can you fuck off, please? Can you fuck off? I don't know why they put that button right next to comma. Super weird. Yeah, I didn't expect anything to change there. Unless my concept of inside and outside is inverted, but I doubt it. Yeah, no, it really doesn't seem like it. I'm almost, you know what I'm considering? I'm considering just getting rid of the triangle, the triangle clipping stuff, and then just seeing what it looks like without it. This is exactly what I expected it to kind of look like. I think that it probably isn't even, it's probably bottoming out now properly. Yeah, it is. But yeah, obviously the tops of the things aren't going to get included, because they're just going to get discarded. But it is kind of interesting that even with that, the bounding boxes overlap so heavily. Maybe once again the bounding box is not the correct way of going about rendering it, such a thing. So instead of render A, B, B, what we probably should be doing is rendering all the vertices, which is what I'll do now. How am I, man, it'd be great if I didn't have to, do this. Let's get main vertex so that I can actually give it color. Nah, yeah, let's not do that. Let's not do that. Here's what we're going to do. We're simply going to GL buffer data. Why is buffer data not at the top? That would be really nice. Array buffer. We're just going to do the raw vertices. I know that I fucked that up, by the way. I'll fix it in a second. This is whole the buffer. This is and then we'll just draw it as GL points. And I'll be able to just uniform in color if I need to. Okay, so that we need to specify point size as something big. That's the thing, I think. Okay, there we go. So we got rid of the vertices that were supposed to be up there. Now the good thing about having this like this is that I can go into wireframe.frag, take in a uniform color and just set this to color.rgb. Okay. How are we gonna do this? Oh hey, what's up, Anna? Thanks for stopping by. I'm having trouble with my mesh decomposition right now, but I'm doing all right. Hope you're doing good. I'm just gonna do I'm just trying to get like a random color per one, and then I could do just like what else is specifically I don't know. Is it decomp decimation? It's kind of like that, yeah. It's kind of just like basically I'm taking every concave face and I'm splitting the mesh recursively on the plane of that concave face to get convex meshes for collision purposes. So that's what it's about. It's just gonna be white, I guess. I don't know. Dude, like all right, peace out. Okay, so they're all of the points have no color. Oh my gosh, dude. Passing shader program to what? Oh, I didn't. Oh. My dumbass. Wait, what? Debugging stuff like this pisses me off. Because it feels like such a waste of time to code stuff that doesn't matter. Okay, we finally got something. Some gradation to tell which vertices belong to which box. You could probably do it like better if you just like do something like this. Does this work? I guess. I don't know. Okay. So going back to what I was doing before, let's put back the triangle. So the triangle stuff is what's hold on. Before we do that, I want to try splitting the other way and inverting what we have again with just the basic points. We do get this. We do get the outline here. We don't get this one. We do get the outline properly. There are some points that get dropped though on the edges. So yeah, this is what I think that it's supposed to be this way. Because this is the way that I originally had it. This is the way that it makes sense. But not getting the points on this side is confusing. Is this for fun learning, or am I planning to use it for something? I made a game engine before, but that one was kind of like janky. This is like what I started this channel with, and then I worked on like other graphics projects for a while, and now I kind of want to make like an actual like an art piece, you know, and so I guess that's what this is going to be used for. I guess that, you know, and so something in my last engine that was bad was the collision system, which was, you know, Jarvis March tolls and not really like an actual not gravity, like a physics thing. So I wanted to make something that has, you know, physics. So So this is the problem with the bounding boxes, right? So this purple point, like what I was saying earlier, how the bounding boxes are messed up. This purple point exists on the hole with those points. So it's completely not contiguous with anything else. So yeah. Yeah. That's what I'm worried about. So this, but it's also this green vertex is here, and then this is the green hole. It's super strange why that and that would... It would probably make sense if we use this and then put it as lines now. Now that we have we can go GL line strip. And I want to see GL line size here, because this is like impossible to... Is it line width? Because I wanna see properly. Yeah, so this right here. Right here. And then this mesh goes all the way over there. And then all the way back. And then this is especially weird and egregious. It's pretty funny, like looking at it now, actually. They are all separate holes. I mean, this right here is weird. That is weird. That we can admit is kind of weird. But they are separate holes, right? I want to see how many holes we have, so that I know what I'm looking at. If the purple ones are like many holes, or if it's, you know. Also, I kind of want to feed in one of our actual convex meshes and see if it freaks out. Like this is freaking out. We have 35 holes. So it's weird that we only have 3 colors, though. I'm guessing that the other ones are just really, really tiny. Or something. Maybe there's just 1 point in each one. And we can check that too. Let's print for each hole. Let's print which one it is, and let's print out the count of the vertices. Okay, we're obviously going to get a lot. So just like I thought, there's a few that just have 3 triangles in them. Or 3 points. Yeah, I'm not sure. So obviously the ones that we're seeing are the big ones, I'm guessing. We could try, what the hell? What was that lag? We can try, we can try doing that. And then let's just bump the depth up. And then let's see what numbers we get. We just eventually start decomposing down to 3. We get a lot of holes. And what does that look like? All right, peace out. Thanks for hanging out. What does that look like? It looks like there's still just the main ones, like 1, 2, and 3 on this side. It's so weird that this one just cuts across, though. But I can see the planes that they cut across, though. That part does make sense. That, like, this one cuts from there to there. It leaves everything behind it to be that one. But it doesn't actually... It's not actually contiguous, right? Wait, no, it's definitely this. Wait, what, am I stupid? I mean, it's kind of fucked either way. Hmm. Maybe if I saw the bounty boxes with this, it would help. Yeah, this helps. Because there's this one that's just 2 points. It's literally just 2 points, 1 and 1 over there. So I'd argue that my method just isn't cutting it. No, it's got to be this. But like, why is that a thing? Why is this a thing? Like, that's the part that confuses me. It just like infinitely recurses in this one area. Like, this makes sense to me. I get, like, to some degree, I guess. To like have some stuff that's going on here. I want to return to printing out these. And let's just see if we still have duplicates in terms of going down. Oh wait, this is only the duplicates that I'm printing out. I'm not printing out the regular ones. So going down, these are the same though. They didn't pass the test. I guess that they weren't. The test was way too clean. So this would be recursing down, right? Like, I'm just checking if there's a cast for a vector that that doesn't get registered, or that happens before we expand something. But I think it's fine. I am doing this inside of the right. Yeah, I am. Let me see this. Like, this just makes no fucking sense, this one. Where it's just like 2 random vertices. Just like, how does that even happen? I think I'm realizing the problem now. Maybe not. I get to the concave face, and then I dot everything towards it. Now I need to make an incision along that plane. I need to make an incision along that plane rather than... Aha, okay. I need to cut based on a plane rather than the normal. Okay, I see. I'm wrong here. The method is wrong, not the code. Yeah, it's not as simple as I thought. You need to check every face against every other face, and then once you determine a split, then you cut along that face. But you have to cut everything, including stuff that has nothing to do with the dot test. You have to make an incision on that plane. Okay, but how do we do that? And this doesn't use a D value, so how is this working? I have to look this up. How to check if a point is above or below a plane. It's and by how much is what I need to know. Assign distance d from the test point to a plane. Standard algebraic equation. Checkpoint relative to plane. Assign distance, okay. Wait, I already do this though. Oh, so I guess that I already have that dot is already the signed distance. Okay. So what we have to do is we have to actually do this here. We just check if there is a split, and then when there is a split, then we decide what to do. Okay, I figured something out here. Wait, hold on, but then I already do this. Also, it's greater than 0. Wait, yeah, it's greater than 0. Is this split? Wait, I'm already doing this though. I guess I already do this. Yeah, I already do this. Maybe it isn't the method then. Maybe I'm fine. And something else is wrong with how I'm doing things. Maybe you don't add yourself at the beginning. Maybe you only add yourself at the end. I mean, you're always going to be an inside face, no? I guess that there's a reason why they said that this was complicated, and I was like, oh, it can't be that bad, right? But no, I guess it is that bad, actually. You got me red-handed. It is that bad, actually. What is this? Yeah. I do get split equals true there. I wonder if it always splits. This is actually, you know, when it doesn't split, actually, but... To the same point down here it gets up there. I want to see the depth. How does depth 0 happen twice? Huh? I call decompose... Oh no, because I'm printing out multiple times. Okay, well, I should just like print it out at the top, actually. That's kind of stupid of me. Okay, so let's see what's going on here. So at depth 0, we do a lot of cutting. Depth 1, less cutting. Depth 2, less cutting. Depth 3, 4. So we have this. See, this is what I wanted to see. This is exactly what I wanted to see. After depth 2, we have no unique points. It just keeps cutting the exact same thing, the exact same way. And then it bottoms out with depth. Then all the way back up the tree, it hits DDDDD, which is vertices count less than or equal to 3 on the right side. On each one of these on the right side, it hits DDDDD, which means nothing is on the right side, and everything ends up on the left. And how the fuck is that possible? SK equals true here. So, how can I be smart? Like, I'm not smart. I'm very confused right now with the code. So, nothing very, very smart about that at all. If SK equals 1, we should just have SK, but it should be fine. That should be completely legal code. Am I somehow just not putting it on outside? Outside vertices count -1. Outside vertices, outside faces. All of this seems fine. What is the idea of the project? I don't really have an idea yet. I had an idea for a game where the game plays itself to some degree, kind of representing the loss of agency in modern society, that sort of thing. Yeah, that didn't change anything. So let's actually check. So let's say when we go into here, let's just print into left child, and then this one's going to be into right child. Just to see where we go down. So we go into left, into left, into left, into left, into left, into left, and then right, 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 right. Everything. Right never splits. Let's see how many each has. Any books I've read? I don't really read a lot nowadays. I went to school for literature actually, but I don't really read a lot now. 6, 6, 3, 3, 3. It's right 53. Maybe it's fine. But the weird thing, into left 305. I put this on a different line, but it shouldn't matter. You can still read it. Into left 201. That's a lot. Into left 252. What? Am I reading this wrong? We hit depth 1. Into left 252. We ended up with more vertices. 287, 280, 299, 305, 311. This is just those vertices. So it's not getting anything on the outside vertices. What the fuck are we talking about, bro? Okay, let's try doing this. We've somehow made a tree that only is on the left side. $252, $287, $299, $305. Fuck. Hold on. Get rid of this, and let's see. No, that was way longer. Maybe that's why everything was on the inside. 252, 287, 305, 311. Everything on the right is so much less. I mean, maybe not. Yeah, it's just the left just keeps on getting bigger, like 335 at the bottom. It's supposed to be getting less indices because it's supposed to split. but it only keeps getting more indices. So the same triangle is splitting every time, again and again and again. Wait, hold on. Did I... Are you planning to jump to study compiler theory and start writing my own compiler? No. No. I have no interest in making a compiler. Hey, what's up, Lily? Shit. It's splitting on the same triangle again and again and again. So how do I avoid this from happening, actually? That's a hard one. Okay, so if you... Okay, so here's the problem, right? Here's the exact problem. We have a plane, okay, that is a concave plane, and we cut on that plane, right? But we cut on it and we find a triangle that's opposite it, right? And we cut that triangle in half. The problem is that there's a little bit of that triangle that is still there, that we're cutting every time, and that's why we have the same thing every time. And so we just start making more and more triangles. Every time we make more triangles. This one's actually funny, the beginning, because we start with 201 points, and then we end up with 252. Triangle plus tiny bit divided by 2. You would think that it would be that easy, but then it's not going to match up. The left and the right need to match up for collision purposes. That's the whole thing, right? Is you want to have one on the left and one on the right, and they match up. So I have to figure out a way. I could easily just make a thing that just says, hey, if we just, if the parents split those triangles, don't get those points again. But yeah. Let's see what's on the left and the right. How about this? Let's see what is on the left and what's on the right. Instead of just what's on the left. I was doing into left and into right to see when I go into each one. So yeah, this is another problem. So our right always has less and less and less and less and less, while our left just grows. This one's pretty funny because this is literally the same point every time. So my way of dealing with those duplicate points was to just treat it as an inside face, and then, not get rid of it, not deal with it. But I don't know. Maybe I should make it an outside face. Because technically it is... Well, half of the face is on the outside and half of it is on the inside. But maybe it should be an outside face. Holy shit, did I just fix the tree with that? 195, 149, 246. No. No, yeah, it still is growing. Maybe we need, okay, maybe we need an epsilon here that's bigger. Okay, that epsilon made a lot of shit. Why would it make more? What the fuck? Look at this. Into left 195, go into child, into left 299, 229. Into right 6. Okay, this is a lot into right now. Okay, now it seems kind of even. The weird thing, though, is that I'm confused. I'm very confused. I mean, what can I say? It's pretty confusing shenanigans, you know what I mean? Like, look at this shit, by the way. Like, what the fuck is going on there, huh? Like, why do they have that many points? Why, like what? Like, what the fuck happened down here, man? Fuck. What if I just make it really... Why is it causing more splitting when I do that? It should be causing less splitting. I'm only supposed to be making holes in the leaves, so maybe what I should be doing is just marking the leaves as leaves. For example, this one, this would be a leaf that didn't get split. How about this? How about this? Let's just only count the valid leaves at the bottom of the tree. Let's just try that. We're just missing some points. Yeah, I don't know. I'm kind of stuck, to be honest. Okay, this might take forever. Maybe there's something really stupid that I'm doing with the recursion, because we should not have this many triangles inside of the children. Like, I use faces count. And I start all of them at 0. We know this. So we use the parent counts. And we start pushing onto our own buffers. I think that there's something stupid that I'm doing with the recursion. That's my take. Hold on. No. How does the tree keep getting bigger is the question. I mean, the answer is probably the triangles that we're splitting just make it infinitely bigger. See, this is kind of what I expected when I built this thing. Was something like this. Except for the one big whole bounding box that holds the whole thing, of course. That's not supposed to be like that. But having a hole that's here, like, kind of makes sense. And we're obviously, you're supposed to have this there. Do I have... Yeah, we have only a whole count of 5 with this. Yeah, as soon as we start splitting... This is just with no splitting triangles. No... Yeah, none of that. We could... Okay, here's what I'm going to do. I'm going to make it so that we can never split on the same face twice. We should never have to split on the same face twice. That's what it is. That's how you fix this. How do I pass down that information? Simple. In integer. I can't believe I didn't think about this before. Based on what I'm seeing, we did not succeed. Look at this. They're like barely the same. That's fucking funny, man. That's fucking funny. Oh yeah, there's no guarantee that they're the same face because we push them differently. So that's not a good way of doing it. Um fuck. It's the correct idea though. I could simply just pass down the actual like points just to prove that I'm correct. Um Oh fuck. Wait a second. Wait a second. Wait, why doesn't that work? Because it's in the parent face, not the child. If only we knew what the split face was inside of the child. We do know it actually. We can get it here. And then just pass that down, because that's where it is in the array. There we go. Okay. No, we're still getting this shit. We're still getting this shit at the bottom. But maybe that's normal. It's not like we're doing the same points again and again. Yeah, let's just do vertices that count. Vertices count less than or equal to 6. Yeah, we do have some funny business going on here. Like, this is pretty funny. That can't be right. Into right 81, and then we end up with more triangles than we went in with. Let's go to depth 10. We're missing some because we didn't do this. Holy fucking shit, that's a lot of holes. There's also one that's just, you know, a little bit funny. A good test to do, I think, would be to test each point that we add against our all of our points, which sounds expensive because it is, but I think it's necessary. We need to not only check for equality here, but also against all of our current vertices. Because we're adding the same points multiple times. Alright, I made another conditional. Well, that was a lot. Really? I'm surprised to see that many duplicate points still. I mean, to be honest, it's hard to tell if there's duplicate points. Definitely a lot of holes. I'm very surprised about that. Very, very surprised. Oh, I don't have a way to split on current split face. Yeah, I didn't do that. Some things here are like, really? Like, like what? Like, really? Oh no, I'm supposed to do this over there. Yeah. Yeah, you're just supposed to do that. Really? Oh, by the way, this is sketchy to do that. How many splits did I get there? I think it's time for another coffee. I'm quite annoyed though. I'm starting to think that there isn't a typo, but something else, I don't know. Really? I don't think that that's correct. It's supposed to be... Maybe not. Yeah, but then again, like, if you have these two faces, this is gonna be... This is not gonna come true. Wait, I'm just doing exactly what I already have now. That's the exact code that I have already. Fuck. You're kidding. You're fucking kidding. Yeah, you can't do that because you need everything that's above it. You need everything that's above it, not just... Oh, maybe I have to put it only in the left one. I could keep a list of faces that we've already split on. That might be useful, I guess. I don't know. I could do that. I wish that there was a way to visualize some of this stuff. I mean, we do have a way to visualize all the points that we make and shit like that, but yeah, I think I need another coffee. I'm just trying to think of like what else I can try doing. Two weeks in a simple 2D water sim. It's not a, you know, really I'm just stuck on something that's kind of silly right now anyway, but it's not that complicated at all. Like really, it's just something's not working like I want it to work. And we can all relate to that, huh? I just want to put continue. Maybe like my fucking loops are fucked up somewhere. I don't know. It's definitely the triangle clipping code that's giving us problems. I wonder if I'm doing it correctly, the math itself. That might be the problem. Yeah, I don't know. We could debug print out all of the all of the points, like new points, but also debug print out the other 2 points, the other 3 points of the face, and maybe that will tell us something. Let's just print out the normal. Fuck. Alright, let's see. It's just gonna print out a bunch right now. Okay. So let's take a look. For example, right here, it's a pretty small triangle we're making. The points of this, the daddy triangle, are 7, -5. So this is a massive triangle. And we're splitting it at 0. Oh no, this is the normal. We split it here. We need to have the D. I need to see the of all the 3 points. Because that looks wrong. Let's try to go closer up the tree, because I think that that's where the problems are also. So we have 2 points here that are very similar that we create. We have 2 points here that are very similar that we already have. So this is like kind of the problem, but you know, look at these points. They're like, this triangle is like the tiniest thing ever at this point. And we have a normal that's cutting it right, like at -1y. Just like one flat plane. And it just cuts it like this. What I wanted actually was TA normal, to be honest. I really want to see the higher parts of the tree, like the first splits. Let's see if the math works out. So we have this triangle, kind of weird shape, but it's fine. Insane TA normal. Insane. Wait, why don't I have the D values? Did I go? I think I went too far. Okay. Oh no, yeah. Why do I not have D values? Ah, here. Okay. So we start with the same thing. It's above 2 in Y. It's hard for me to picture this shit in my head. I'm looking at TA normal, right? Why is TA normal changing? I have TA and TB. I'm looking at an old one. Okay. I need to be looking at TA normal. I want to see what TA normal is like. TA normal and TB normal are exactly the same here. Exactly the same. That should never happen. That should never... Well, actually, never mind. Because the D value does change. And the D values are correct. 1 under, 2 over. But it's hard for me to picture it in my mind, right? The Z is just -1, right? And so it's splitting it down the middle. Like I said, I wish I could visualize it. So I feel like it would make a lot more sense if I could visualize it. Yeah, that didn't really tell me much, to be honest. Just kind of annoying. What we could do is only if DK is greater than this amount, That did nothing. Still made 91 holes. Alright, I'm getting a coffee. I'm, like, zoned out of this. Like, it's... Yeah, it's really taken a toll on me, to be honest. This shouldn't change anything. If it changes something, then there's something wrong. Okay, well, it didn't change a thing, so... Yeah, I don't know. At this point, like... It's... Maybe, like, my concept of inside and outside is incorrect, but, like... I don't know. We shouldn't have, like... shit that overlaps so much, and so I think I'm somehow creating triangles that are outside the bounds of what we have currently, which obviously should not happen. Yeah. Hold on. Wait a second, I think I did this wrong. Wait. That's supposed to be... No. Yeah. Uh. Yeah. 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 Now, of course, there could be like different winding here. Like technically, OD is supposed to be first, I think, but it shouldn't matter because our normals are carried over. So our it's just the indices that are the thing. It's not actually. And yeah, technically this should be the other way around, but it shouldn't matter because at the end of the day, the points are just the points. Trying to think of anything that it could be. But the thing is, like, even here, like, our D values are always high. Like, if it was that our D values were super, like, minimal, right? Like, that would make sense. That we're, like, cutting faces that are really close to us. I'm thinking I have, like, an algorithmic problem rather than a methodology problem. What happens if I remove our own faces that we're splitting on from it? We still have overlap, which is strange. Like, if we're cutting things properly, then there should be no overlap. Like, there should be zero overlap. Alright, I'm getting a coffee. I'll be back. Okay. I'm waiting on my coffee. Okay. I have no clue. Um, I have no clue. I'm thinking... Hey, what's up, Luca? We are light mode coding. I want to see how many splits we get when we branch. Okay, just like... This is what I care about. Like, once we get down here and we're splitting, I want to see... I'm alright. You know, just doing my thing like usual. I did not get a programming job. I failed. But that's alright. Okay. Okay, there's a shit ton of splits. There is a shit ton of splits. There's 134, 130... Oh my god. Wait a second. We have the same amount of splits every time. Okay. Okay. Let's see the current split place. Anyway, what I'm working on right now is I'm working on concave hole decomposition for my collision stuff. -1? What? Nah, you're lying. You're lying. Oh no, never mind. I commented this out. I did comment that out. I'll get one soon. Yeah. Yeah, I would believe you. See, so there's more splits every time. Fuck. Is it possible that my normals are fucked? Have we considered that the normals are fucked before? Do we have a centroid, for example? Does the mesh... I mean, the mesh has an AABB and a center, yeah. So let's just do this, right? How do I do this again? Then I just take P. Okay, so if P minus the center, and then dot it with the normal. If that is greater than 0, then we have a problem. It's either greater than 0 or less than 0. You've not touched a code editor? What have you been up to? That's crazy. We have a problem. Oh no. Oh no. Did I do it backwards? I hope I did it backwards. We have a problem. Okay. Wait, so... I don't trust the deduplicate stuff. I'm not gonna lie. I feel like the deduplicate stuff... Let's just stop deduplicating points. Let's just see. It's like if we don't deduplicate points. Bro, I'm starting to feel like I don't know what the fuck I'm doing. Wait, wait, hold on a second. Wait, do we... No, I got rid of it. Damn it. Mainly checking out a few countries to move to. Went to hell? Oh, damn, that sucks. That sucks. Have you been traveling around? I do wonder if we have a problem before we get in there. Like that's what we gotta check here. Okay. Do we have a problem before we start recursing? No. We don't. Huh. And I assume we're gonna have a problem in the other direction, yeah? Yeah. Okay. So, our triangles start out with correct normals, and then they somehow become incorrect by chance. By chance. Okay. That's cursed. That's fucking awful. A remote job? Damn, that's awesome. But how did you get a remote job without touching a code editor? Have a year to decide? Dude, I'm putting my vote in for Ireland, bro. Netherlands, you got too much drugs going on, you know. But you don't touch code as a sysadmin? That's crazy. I don't really know the duties of a sysadmin. But I assume that one would look at code every now and again. Can't I dot the normal just with the center straight up? No, I have to have a vector to the center. I most a few scripts, VPS. Do a lot of log investigation. Oh, I see. How do you get that job? Did you like do some kernel business to get goodwill, you know? Set up. That sounds cool though. I personally would go fucking crazy sicko if I didn't touch code at my job. I would I would go insane. I would literally I would lose it, bro. Alright, so we have a problem. Because, okay, so what we're learning now is that somehow our shit gets fucked up, bro. And it ain't even funny. Maybe I'm doing this backwards. Have we considered that? I think maybe we have considered that. I think if you turn this around, then it's just the same thing as going negative t. Like if you just do negative t, it's the same thing. So, yeah. Holy fucking shit. I'm in the fucking Matrix, bro. What's up? Recommended me internally. Still had to do the 5 interviews. Damn, 5 interviews is crazy though. 5? Okay, my computer's gonna break if I let it go. I don't know if you remember it. I do remember you. A basic neural network. Cool. That is sick. I don't know anything about that. All right, let's see if we can somehow fix the normal problem by just playing around with shit. Because really, I have zero clue what the fuck to do. Basically, what we're doing here, by the way, is that we have a bunch of faces and a bunch of other faces, and we're just clipping faces based on if they are before our plane or after our plane. So that's what we're doing. That is what we're doing. All right, peace out, Lily. Thanks for saying peace out. I appreciate that. Like, what the fuck is that? What? Believe it or not, that's kind of like the best result we've had in a while. What happened to the space sim? I kind of got bored of it, not gonna lie. I just kind of got bored. But I mean, I left it in a good space. It's space. But yeah, I left it in a good spot. But I did kind of, I don't know. I got bored. That's what happened. As with everything, I get fucking bored. I don't know. I just didn't want to do it anymore. But I mean, that was cool. I learned a lot about like noise generated terrain and shit like that. You know, like I wouldn't have known that at all before. You know. You know what I'm realizing is that our points have to be correct because all of the points lie on the surface. Like the points are actually, oh, actually this one's not. These aren't. But our points for the most part are correct. When do they get to be incorrect points? Yeah, this is fucking crazy. But all of these points are actually on the face. I'm just looking for points that aren't on the face. Seems like if I have this here, then it gets mad at me. For this hiatus, I was making a financing app and also got hella bored. Yeah. Yeah, some projects I just get bored faster than others. Like with the space thing, like I personally, oh fuck, that's why. Personally, I just like got simply, I don't know, just like there wasn't much to do with it anymore. Like the rest of the things to do in the project were just like optimizing it, and I don't have a good enough computer to like you know, make the clouds any prettier or whatever, and I just got kind of stuck with it. I mean, is this like I mean, this is a lot of holes for sure. But like, is it necessarily wrong? How am I supposed to know if it's wrong? I put vertices count at 16, but maybe this is too high. I don't know. Does it? I think it bottoms out at 10. Like either way. I think there still is infinite recursion in it. Oh, actually, I think that we're now 123. I think that we are exiting out now, though. Like 123 is, yeah. We have a problem still happens though, so our normals somewhere get fucked up. Let's print out those normals actually. How about that? I have no clue how to, you know, how to test those normals, but I've been doing a lot of like macros now, just because I've learned how cool macros are. So I have a lot of these macros that just print out shit and have like, you know, like they print out the variable name and all that. That stuff is cool. Like, say, like it having normal here is, you know, that's sick. -1z. Well, that shouldn't be bad on its own. I'm guessing that the point that it has with it is bad. I'm guessing that the point that is off of the plane is very badly off of the plane. So the point is at... point is at 2... Yeah, I'm not gonna lie, I have no clue how to read that because I'm too stupid, but yeah. Yeah, it makes no sense how the normal would get swapped around because literally we don't actually change the normals when we recurse down. We just keep the same normals. What I could do is do this down here and then just continue on that. Just to see if that changes anything, but no, it doesn't look like it did. You know, if you split a triangle in half, it's supposed to still keep the same normal, so I don't think that I'm wrong about that, to be honest. Does look a lot healthier though. But we still have, the problem mainly is that there's overlapping bounding boxes. Like, the way it's supposed to decompose things is it's supposed to be like, you know, one on one half and one on the other half. But I think it's splitting things at very, very sharp angles to the point where things that aren't near the other things are also grouped with that stuff. So I don't know. Yeah, me doing that fucked everything up. Yeah, you can't do that. What that's trying to do is it's trying to limit the splits based on, you know, how far away from the dot it is, which on paper seems fine, but apparently it's a bad thing. So I don't know, maybe I shouldn't add inside to it differently. The whole point was this current split face thing, though. Wait a second, this looks actually fine. Kind of. Okay, there is 500 holes, though. There is 500 holes, though. But, like, the topology looks fine. There is 500 holes. But the topology looks fucking fantastic. And they are, like, split kind of properly. I wonder where the 500 is coming from, though. Like, because I don't see 500. Maybe you just need, like less here. Yeah, maybe I just fixed it by just playing with it. I mean, no, like, this can't be correct right here. Yeah, my computer fan is going on from this. To be fair, I am drawing them all separately. So that's a part of it. 199, really? I want to know how many duplicated vertices we have inside of it, though. Because I bet there's a lot. If I had to guess, there's a lot. Yeah, if you limit the depth, then it's suddenly not that bad. I mean, 43 does sound crazy, though. 43, you have to admit, is kind of crazy for the amount of holes. Just for, like, some geometry. But yeah, after we decompose, then, like, the idea is just to run incremental hole on each hole. So that would you would just go in a loop, right? But I don't know I don't think incremental hole is hooked up to do the holes with no mesh, with you know, just raw holes. So I have to fix that real quick. Holy shit, I have a lot of code in this fucking file. Okay, so incremental hole, it goes off of this base hole instead of the holes. So instead of just a mesh, what I should bring in is a hole. So pointer to a hole. Do I need this? Mesh hole vertices, mesh hole. No, I don't need the actual mesh. I just need a pointer to the hole. So let's do that. I lied. I made a port of an nvim theme into Helix instead of going to sleep. All right. Peace out. Good night. Yeah, I'll take a look at that and see if it's good. I'm gonna take in a hole, and we're just gonna pass the hole around. And the hole will be everything inside of here. Instead of the mesh used to have one hole, and that's why it's mesh hole. But now we have multiple holes, obviously, per mesh. In this case, 43 of them. So now, is 43 what I really, was going for with the number? No. But that's all right. Sometimes we can't get what we want. I'm gonna have to keep taking a look at it. But like, as for right now, I'm actually kind of happy with how it turned out. Wait, I have to do this. Whoopsies. Why do I have 11 fucking other errors? Because of this. Pick lowest point. Needs to happen over a hole. Oh, and this uses the ABB extents of the mesh, but I will need to use the hole extents, which I do have. We just need to replace mesh with hole, which is not a big deal at all. My coffee is probably almost ready, or it probably is ready, but I'll just keep refactoring this because that's what I do. Why is there 17 errors? There was just 11 errors, and now there's 17. Set up initial hole points. Okay, we're getting to the end here. Because we just get rid of this, and then it's voila. Okay, 12 to go. I could have just written this, this way the first time, and then just have the whole not be a separate thing on the struct, and just be a pointer into the array, like like a normal person would fucking do. But that's all right. Somebody should make something so that when you're refactoring something specifically like this, when you delete the thing on the left, it'll automatically turn the period, the struct reference, into a pointer, an arrow. Like, that would be like insanely like quality of life. Like, that would make me so happy. But no one ever is going to make that. We'd rather build agentic workflows, bro. Instead of shit that I can actually use. we're gonna go holes.count, and we will call incremental hole on all of them. I need to cast this vec. And we will I will call it incremental hole on all of the holes. Okay, and now how do I actually render that? I have no clue. Oh, we can figure it out. I have this thing that goes over whole faces, which we could do. Did I have a thing that prints out triangles? It into triangles? So that would be nice. This is triangles. This is triangles. Okay, so then let's just do this, but let's do it in a loop. Okay, let's just go through all of them. And we will, we need a, let's just cast it the same way we casted it here. Redefinition of holes. We're just gonna do that because I don't give a shit. Okay, and we get rid of that, and that's good, that's good, that's good. And now we just do this, and just all we're gonna do is free the triangles buffer and draw it to the screen. Did I do this correctly? No clue. I'm adding into T, which I'm expanding from triangles, which I make here, and I init it, and then we free it. Okay, that sounds good to me. Tries, we make new tries, that's fine. Okay, let's give it a shot. It is triangles, so I can get rid of the wireframe. And let's see if we segfault in init.h. I have a init.c. Yeah, incremental hole on the mesh. Oh, that's a problem. That's a big problem. Actually, no, it's not. It's just hole. It's just this hole. You just use that hole. Oops. And we died immediately. Fuck, dude. Okay, to be fair, I haven't tried making holes with, you know, that may or may not be, we need to see, you know, how many iterations we're doing before we crash. Why? Oh, I'm guessing it's the player one. If I get rid of that, maybe we can see. No, we do die. We die at the second one. It's possible that I need to check if these holes have more than 4 points or something. Also, my computer fan is going like crazy, and that's really pissing me off. That's really starting to piss me off. I may have to just restart the computer, which sucks. It may be a problem that I don't init the faces. Oh, I do init it here. I do init whole faces. Not sure. Alright, I'm gonna get my coffee. Okay. Let's find this bug. Oh, my computer fan went away. Nice. Okay. So what is the problem? Let's just GDB it right away. Set up initial hole points at point's lowest index. Okay. Oh, the cat. Point's lowest index. Pick lowest point hole. Does it say? I didn't BT. Pick lowest point. Lowest equals infinity. Index equals 0. And the point is the whole vertices. So the only way this would be bad is if it's either not allocated, which I'll check here, or if there are no points inside of it. So let's see. See which one it is. Oh, whoops. I just fucking... Can you fuck off, please? Okay. Let's see. Yeah. There's no vertices on the second one, which is confusing. It is confusing why there are 0 points on that one. Huh. Okay. Or it just gets deallocated somehow. That's also something. Let's print out for each one. Also, it had a count of 0. Let's see if it changes later or something. Maybe something is wrong. This is gonna be... Okay. Okay. So now there's another bug because I made it so that we don't push holes with 0 vertices. Now we're running into a problem with rendering at t0.pause. Okay. I think that this one's probably going to be easy. Main vertex. That's correct. Try indices 0. Indices 0 into points. And points is vertices. Okay. Okay. Well, fuck. I want to see what the index is, and I need to see because this is after incremental hole, right? This is after incremental hole. Hole vertex count 18. And then we don't get to see the indices. I'm guessing we don't get to see the indices because dereferencing the triangle. Oh, wait, hold on a second. This vector expand is wrong, apparently. I mean, hopefully it is. Why would it be wrong? Or maybe GDB just isn't giving me correct info. Oh, source file is more recent than executable. Got it. Okay, so it is the triangle itself. Once again, let's check the pointer. Let's check the faces buffer, obviously. So that's the one that we're looking for. Let's try to call this H, just to make sure that we're referencing the correct hole. This is crazy. I don't know why this is happening. It's the second hole, right? It's the second one. 24, 18, 66. What's also interesting is that the holes start at 1. That's interesting. I don't know why that is. Is it because when we load them in, we do something with the holes? Hopefully not. I don't think so. It's weird though. Oh no, it's because we print it out after we push it. So we print it out after we expand. So that does make sense why it starts at 1. 0, 2, 0, 1, yeah. Okay, let's see what that tells us then. Fuck. What? The faces count is that much. Okay. So we gotta take a look at our whole incremental hole, I guess, for that. Also, I'm noticing some printouts that I don't want, like the depth and this shit. So let's just get rid of that while we're working on this, because that's gonna piss me off. Okay. Now let's go into incremental hole and see what could be happening here. While we're doing this, just like go after incremental hole and then just exit 0. just so that we can iterate fast on this. Okay, so points. Where's what I'm printing out? Whole indices. Oh yeah, whole indices. Okay, so whole indices is always a good number. Okay, so that seems fine. So how is our faces.count? Faces.count equals whole indices.count. So how does our whole faces.count end up incorrect? Wait, hold on a second. Two exits out early. Hold on. I think we're not getting past setup. Yeah, we don't get past setup with the second hole. And so what happens is that it never gets initialized to anything. You can fix this bug by going holes I that faces dot count equals 0. It just never gets initialized because it doesn't make it through this. It just doesn't pass the test. I'm not sure how that is, but let's try to move on, and then we'll keep that in mind for later, that one of the holes is broken. It looks like it's literally just one that's broken. So okay. Can we stop rendering the other thing so that we can see what it is? It looks like the collision doesn't work. Oh, the collision doesn't work because I'm fucking stupid. Because I turned this off because I thought that there was a bug with that. Okay, there is a bug with that. Points 0 0 0 0 0 0 0. Huh. Okay. Oh. I see. This is supposed to go on. Okay. Well. Okay. Let me see if we actually are checking against this one. We do check against... Oh, but we don't check against all the holes, of course. So since we don't have the acceleration set up yet, the acceleration structure, you just go. Okay, now it may be slow, but we do have collision now, probably. Equality found. Okay, so Okay. By the way, these are all the holes drawn on top of each other. I believe so. That's what we're rendering. At least I think so. Like if I turn that off, we won't render anything. Okay, so the holes look correct, but they aren't correct. How is that so? It's so weird. Why? Blue is up. And yellow is down. Where is equality found? Well, shit. I want to make sure that its offset is 0, 0, 0. Equality found. Maybe get rid of this. Why does it not work now? Do I set the M pause somewhere else or something? What did I do? Fuck. Oh wait, hold on a second. I was supposed to go. I was supposed to go. I was tweaking. Okay, there we go. Assertion failed. Vec3 dot inside F2 normal. This part seems a bit weird. Right here. We just go up on top of this thing. I wouldn't be surprised if there's some reason for that. Like, that's supposed to be a flat face, but it's not. Like right here. Yeah, it's kind of bumpy right here. Where the two holes don't match up. Like right here. Alright, let's do some testing with, now that we are doing the holes, you know, completely. Let's go ahead and test what it's like to set it to max depth. Yeah, really, at max depth, it doesn't seem any better. Unless that's where that face is supposed to be, but it feels like, nah, yeah, you're definitely above here. I want to render the points again. How do I render the points again? Where's that code to render the points again? Don't I have a function that Yeah, it was this. Yeah, it was this. But why? Where's the meat inside of it? Did I delete it and then put it somewhere else? God fucking damn it. I don't want to have to write it again. Shit. That's so annoying. Maybe I don't. Oh no, I don't. I just draw the vertices themselves. Hello? Hold count 0. Hold count 0. The fuck? Oh, M2, 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 M. It's the pointer was at the wrong spot. Okay. So now maybe we can see what's going on here. It doesn't show that there's a point here. It doesn't show that there's a point here. Maybe we should look at the collision code then. Maybe the problem isn't actually with my thing. Maybe that's the hole that doesn't get anything inside of it. Maybe I have to skip it, I don't know. Right, yeah, we got around it in here. We got around it by doing this. but setting the faces count to 0 always. Maybe we should make sure to get rid of it in when we do collisions with it. I think that's what I'm gonna do. If we try that. I would accept this if it didn't render separately, but maybe this is a separate hole that goes over it, but it doesn't render. Like, it doesn't render this way. That, like, why does it not render like that? It should render a surface here if there's a hole here, you know? I wonder if there's anything that I can even test with GJK to see, you know, if it really is a GJK problem. We could also turn off EPA and just return a Boolean and see if GJK is telling us something else then. But we do get a Boolean back. It's almost like there's a point over here and then a point over there. Over here or something. Fuck. Oh, it's also here. Like, this is connected to up here. Like, I would be fine if it at least rendered in that same manner, but it doesn't render like that. Like, how can that be the case when it doesn't render like that? Like, I'm visualizing both the vertices and the faces. So there's literally nothing else it could be. I'm visualizing both. I forgot to set the fucking thing. Like, here's an interesting one. It's like, why am I... Now this one kind of makes sense if that's the case. If that is really connected, because then that makes sense why the whole hull is massive. Then that makes sense. But that one still doesn't make sense because there isn't a line here that proves this. Unless you need line loop to understand it. Then you see it. Okay, so I'm not going crazy. It just doesn't... The points, there are extraneous points that aren't the ones that are on the faces. That's the problem. Because the mesh itself looks fine, but the points are wrong. And so I think after we do whole decomposition, mesh decomposition, what we need to do is remove all of the points that aren't referenced. Also, I gotta take the coffee off the screen. Okay, I think that's what it is. We can call this clean up hull. And this is just going to remove extraneous points from hull. Now, why this is a thing, I'm not really sure, to be honest. But whatever. We can also deduplicate here, which does have some amount of value. Then we want to don't I have this written already somewhere where I look for fuck, I would have no clue where this is though. Oh, it's basically just the horizon edge code. It's basically just the horizon edge code. Maybe a bit different, but so all we're gonna do is we're gonna loop through all of the faces and just push shit that we haven't discovered yet. It's that simple. So we're gonna need a new points. We're going to init vector new points to a size of 0 with the type size of vec3. What are your best philosophies? You like Kierkegaard. I don't know about Emily Swaron, or however you pronounce that name. I went to school for literature, so I was more into literary theory than pure philosophy. But you know, in terms of just in general philosophy, like I don't know. I tried reading being in time and like I don't know. Like what was influential to me in terms of philosophy? Not much, to be honest. I was more like a literary theory guy, like Lacan and stuff, you know. So I don't think that counts as philosophy, but you know, it would be that, yeah. We're not gonna cast it. Is that Helix? It is Helix. It is. It is. This nested loop is kind of necessary unless I do a hash table for it, and that's really not what I want to be doing right now. Okay, so we're going to go through all our new points, see if it exists, and then if it doesn't, we'll add it, right? The tricky thing, though, is that we have to change every reference to that point to the index. So we'll figure out how to do that. So if vec3 equal, and we want it to be exactly equal, of course, for this to work. You need to do in here. Besides graphic programming, are there any projects that touch any other fields of programming? Obviously, the chess engine was pretty much, not graphical at all. Other than that, most of my stuff at least has like a graphics element to it. I just really like graphics programming. I like the ability to, see things. I like the challenge of it, obviously. It's just a lot more hands-on, And it's also like an insanely good challenge, I like the math and all that, You get what I'm saying. You get what I'm saying. Okay. So if it's equal, then we found a reference. Right now we'll just have a Boolean. Okay, and then from here on, we need to figure out, if is new. If it wasn't new, then we need to take the old. Yeah, you might as well just handle that in there, huh? Yeah, because we need the index. So this is going to be awkward, but I should probably just make a different function that does that. But yeah, hold on. Let me try and figure that out. I need to make all of the other places that reference that point the new index. Actually, if it isn't new, then we just change this face's. Yeah. Okay, actually, this is completely fine. So this face indices j equals k, and it's that simple. And then we just break out of this. Yeah, and then if it is new, then we need to at least change all the references. Oh, actually, if it is new, no, then you just add it, because then everything after it is going to see that it isn't new. Okay, so that's completely fine then. So we're just gonna call. We're just gonna call expand on new points by 1, and then equals p, and now we'll set face indices j to equal this new points dot count -1, And that's literally the whole thing. That is literally the whole thing. Faces is declared there. Okay, and what is the problem? Use of undeclared identifier face. What are we talking about? Maybe it's all of this shit that I didn't use. Yeah, that's what it was. Okay. And now all we need to do is just free the old buffer. Free whole vertices dot buffer, and then whole vertices equals new points. We're just gonna keep that vector, and that's that. That's that. And so every time we push a new hole, we will clean up the hole. So we're just gonna call cleanup hole with this hole whenever we push a new one. Okay. Now I have no clue if that's going to solve our issue. We do crash. Can we try to get rid of deduplicate? Let's see. We crash again. Okay. So let's try to figure out what's going on, huh? I'll GDB it in a second, but okay, so we init a vector vec3. Take our old whole vertices and our old whole faces. If whole faces dot count is 0 or whole vertices dot count is 0, return. I don't think that that's ever gonna happen, but might as well. Might as well. I'm guessing that we're freeing this buffer and it's bad. Or something. We don't even get down there. Okay, well let's just GDB it at this point. This is ridiculous. There's something stupid I'm not figuring out. Okay, so old vertices face indices J. Faces I. Face indices J. Old vertices. And clean up hole. Oh, right. Okay. Okay, so this was just me being silly. Instead of clean up hole, we should take in the vertices and the faces. The reason why this is different is because we only store the vertices on the hole in the beginning because it's supposed to just be a point cloud. But for this, we want to be referencing what we have on the faces. So in this case, we should be just giving vertices and faces into cleanup hole instead of this. So this is my fault. Okay. So we're gonna have to do some shit here. Redefinition of faces with a different type. Mesh face pointer versus... Oh. I don't want to take in a double pointer. I'm sorry. If we've got some double pointer fans in here, I'm just gonna take in the whole additionally, and we'll just oh, actually we don't have to, because this is a vector. All we have to do is replace in vertices with new points, because it's a wrapper struct and not just a buffer. So there's no need for a for anything fancy. There's no need for a double pointer. Oh, you want to make sure though. You do want to make sure that you are doing the whole vertices here. That is important. That is important. All right, let's give it a shot. Okay. It's exactly the same thing. It's exactly the same thing. That's fucking hilarious, actually. It's exactly the same thing. What? Fuck. If vertices are less than or equal to 0, return. That makes sense. But why does me changing this, getting rid of that, cause some issues? I don't understand. All right, let's try some things out, I guess. Yeah, that does nothing. All right, it does do nothing because we got rid of it. We did get rid of it. Aha. Okay. Well, we hit an infinite loop or something. Let's try just the duplicate points. Holy fucking shit. We've spawned in and we we have 7,000 holes. So it's a bit choppy, guys. Okay, yeah, this is obviously not fucking good to do. Let's just try the duplicate points. Yeah, that doesn't seem to do anything. Let's try this, but with a depth of like 10 or something. I don't fucking know. Oh. Come on. Like. Now, yeah, we still have this problem. We still have this problem. In fact, it's gotten worse. Yeah, it's gotten worse. I don't think that changing the winding on any of this matters. But we can try. It shouldn't. It shouldn't. Wait, it did change something. $2,000 holes. Yeah, you can't do that. What I used to have was I used to do this in here. But obviously that's not that great. That's really bad. I wonder if it's the split face thing that's the problem. No. I don't know why it's so bad. Yeah, I'm stuck. I mean, not like stuck like impossibly hard, but yeah, I don't know. Oh, this is so hard. This is like the hardest thing I've ever had to do. Like, what the fuck are we talking about, bro? Like, this is stupid. All right, I don't think my code is wrong. I think that I think that I'm just at a point where I probably need to like look at some other implementations for whole decomposition to get some ideas because I don't think that I can figure it out just myself, to be honest. Because like the math is working, right? Like it just sees these points that are visible to one another and it just groups them together and it just discards the middle. But that's not how you make a convex hole. You can't just have fucking empty space in the middle. That's the problem. That is the problem. Um, okay, let's take this triangle for example. This triangle right here, or this triangle or something, right? Like this is a convex face, a concave face, right? So it's gonna see everything there, and it's gonna dot it, and then it cuts it, right? Cuts it like that. Okay. The rest of it should group together, right? Or this, like it cuts everything off beyond that, right? And then it. I'm gonna lose my mind. I'm gonna lose my goddamn fucking mind. I'm surprised that I didn't see any difference when I did this. Saw no difference. Like, is this doing anything? Like, if I just do this, does everything break? No, it's not. Oh wait, no, because our face indices don't matter afterwards. Right. Now if I get rid of this, then everything's gonna break, right? Right, yeah. There we go. I wish that there was a way, like a heuristic, for me to see, like, if there's like a face that's dotted away in the middle of them, because that would change, like, I've got a couple ideas though. Let's do a depth 2. Let's see what it's like on depth 2. On depth 2. That's connected to there. Why? You know what I don't understand? I don't understand. Okay, there we go. There we fucking go. So maybe I need to call cleanup hole after I call incremental hole. Maybe that's the thing. Let's do it. Let's when we go incremental hole, let us call cleanup hole with hole vertices and hole faces. No, yeah. The faces are right, but the hole is not. So that's useless. The faces are correct, but the point cloud is not. The point cloud is not. But how is that the doesn't make sense. It doesn't make sense. I'm still flipping this back and forth, like, bro, like it's gonna help me, like, dude. I could try like a negative epsilon. That actually kind of helped, but now there's this shit, which is pretty funny. Like, that just goes over the whole goddamn thing. The problem is that the same point can have different normals, which is kind of fucked. Honestly, I feel like the easiest way to do it is just to like fucking just do like regular, normal BVH splits or whatever, and then just hope that you luck into convex holes. Like what I'm doing here, I don't think is possible. If I just do this and just automatically put them on the outside, what is it like? It's honestly like the same. What's my depth? 5? You only get 12. The weird thing is this, right? Like, why is this and that? Why are those getting put together? Like, it doesn't make sense to me. I guess it does if you're splitting on that plane, on this plane. But no, but then this is not on that plane. This just, I mean, unless it really isn't. Okay, maybe it isn't. But then how do you I mean, maybe the easier way to think about it, right? Maybe the easier way to do it, instead of just going on that plane, maybe the easier way to go it is just straight on a certain axis. Just like take but then that's like for just for this case specifically. What's the heuristic, man? Maybe I could do a similar thing like with what I do in incremental hole and look for horizon edges. Like, if I have just this face, let's say, and I'm looking to split on it, and right now we just split like this and then get that. Maybe splitting like that is fine. All we have to do is make sure that all the triangles are contiguous. I feel like that's not possible. How do I check if things are contiguous? Like, if I just check for horizon edges, then yeah, it's not gonna work. That doesn't work. I could just make sure that that edge is something is an edge that we already have. It's connected to an edge that we already have. Every triangle has to have an edge that we already have in the fuck, man. I have another idea. Say we have a concave face, like this face, right? And right now we're just splitting it like that. What if we instead search for the closest D? The closest D, because then we would find this point. We would find these 2 points in this case. And then upon finding that closest D, just straight up go down the center. Or something like that. That way, we get none of the bullshit where it like gets stuff from over here. And it's a solid heuristic that can be used for every single face. Get the smallest D that you can, and then just cut straight down. But what is straight down, I guess? I would say that you just average the normals together and then cut there. Or something like that. And then you just cut on that plane. But you would have to rotate it. I don't know how to do that. But yeah, you do that. So what you do is you get a face, you check if it's a concave face. If so, you find the absolute smallest D that you can, and then you cut there. How do we find the vector down, though, without just like saying that we're just going to cut downwards? Like, how do we I think it's called the bisector. I have to look it up. Find perpendicular bisector between two normals. That's what I need. Calculate the midpoint of the endpoints and use the director parallel to the line. Average the coordinates of the two normals, find the slope. In 3D, the normalize and find the line that bisects the angle. Okay, so it's not telling me anything. What am I doing? I'm trying to find a way to decompose a 3D, concave mesh into convex meshes. So the method that I'm currently using, right, it takes a concave face like this one, and it simply cuts it into two halves, right? And then it recursively keeps cutting until we have convex meshes. However, the problem is that you end up with things like this, where now, of course, in GJK we can walk on this surface, right? When you're obviously not supposed to be able to walk on that surface. So what I'm working on right now is how to make a method that keeps things contiguous, right? It's not simple because I have to make it work with meshes that aren't just like this, just blocky messes like this, right? So there's a lot that has to happen, and so I have to figure that out. And so the way I'm thinking I might do it has, but the way that I'm thinking of doing it, right, is to find the bisector between these two normals and then go inward, instead of just going on the normal on one face. Instead, just cut it like that. But I'm wondering, if if this is gonna work on things that aren't this stupid, right? So that's what I'm working on. But the idea, right, is that when you have one concave face, you need to cut it before there's another concave face, right? You can't just skip over and then connect the stuff that's over here with the stuff that's over there. That's the whole point. Also, I'm wondering, now that I'm thinking about this all the way through, I'm kind of wondering if this changes anything, because from what I'm noticing, yeah, that's interesting. That is interesting. That our P does change things, even though it should be fine for each point on the line. When we change it, it breaks things. So I wonder why that is. I wonder why that is. Is it the current split face thing? No. Why does this straight up delete triangles? The calculation should be exactly the same. Should be exactly the same. So what would cause that? Oh, I had this on. So that's probably why. It's because we no longer are doing things evenly. Yeah. That would be why. Yeah, but like here, for example, like this is like, how does that get connected? It's so weird. I guess if splits equals 3, then split doesn't equal true. No, it does equal true, but these points connecting to here is so strange. Like, how does that happen? It's hard to figure out why that happens. It really is. And it's happening without it's happening without any of the stuff where we split triangles. Like, even in this scenario where things get fucked up, these points still connect to the top. So I have no clue why that's happening. Like, what plane is connecting those two? And if I get rid of this, then things break also, for some reason. I should probably investigate this. 0.0. Where's that points printout? Set up initial whole points. So why does that happen? Okay, in decompose whole, I already have this right here, but I guess I didn't have it over here. Yeah, these still connect. It's so bizarre. This starts to become a complete fucking mess when you continue on the own faces. But the strange thing is, like, if I add this face as an inside face, I mean, this is just a fucking mess. This is 268 holes. And like, it's just bumpy and shit. I wonder why that causes an issue. Alright, so let's go back to what we were doing. I think I'm gonna try and split it. I almost like out of curiosity, I kind of want to see if we just iterate it here and then go and find the lowest D and then find the plane to bisect it. So that's what I'm going to try to do, is I'm just going to move this into two different loops. And then in the first one, all we're going to be doing is trying to find the lowest D. Let me look this up again. I got distracted. Calculate the cross product. It's just the cross product. Okay. I don't know which way it's going to be facing, though. So, or is that perpendicular, or is that just averaging them? No, it is perpendicular. Okay. So we're just going to have a... If D is greater than 0, then lowest D equals dk. We also want to keep track of lowest index and lowest yeah. If dk is greater than or less than our lowest D, then we will do this, and we'll set lowest normal equals j normal. Okay, now outside of here, what we'll do is we will say if lowest D is less than infinity. That's the first thing. Then we want to get a perpendicular normal to lowest normal and r normal. And we need to make sure that this is actually perpendicular, but I have no clue how to verify that. Anyway, we want to use this as our plane that we will test all of this shit against. Instead of our regular test. So I'm just going to move everything inside of there. This is ridiculous. This is fucking absurd. Okay. Oh, fuck. I don't know. Am I not missing one? Okay, there we are. Okay. Oh, wait, shit. I fucked up. I fucked up so bad. I fucked up so bad. Oh my god, this fucking nesting is gonna be the end of me, I swear to god. Okay, okay, okay. Split equals true, if this is the case. So we go through all of the faces, and instead of dotting against this normal, we dot against the perpendicular normal. And then we figure out that, and then we do the same exact logic. Same exact logic. Okay, does this make any difference? Holy shit. Okay. We may have forgotten something that we were supposed to remember. You know, it should be the same thing. If I just do this, the code should be the same. Yeah, the code is the same if I do that. Okay. So let's do all of the normals. Maybe I have to negate it. Um, oh, it's not. I don't think that this is how you do it. I don't think this is how you do it, man. Oh, wait. They're equal. Oh, shit. They're equal because I didn't check if I equals j continue. So of course the dot would be the lowest if it was on it. Okay. So this time we got 2 holes and okay. The normals were very similar, and so maybe I have to normalize it. Maybe that's all I have to do. That might be it, actually. No, that's not it. Lowest index K doesn't really... Oh wait, yeah, I could have just done TB indices K. Ask Claude, lol. Ask Claude, lol. Yeah, this is weird that this is cutting it kind of the same. Like, am I crazy, or it's cutting it the exact same way? It's cutting us into 3 holes. Split equals true. But we haven't actually determined if the split is technically true. Ah, there we go. It's pretty much the same thing. It's basically the same thing. And it takes a long ass time. I'm gonna be pissed off if our normals are wrong or some shit. I don't think that they are, but... I don't know. Shit. Like, there are just embedded patterns that we just keep realizing. Like, this and this keep getting connected. Keep getting put in the same hole, even though they shouldn't be in the same hole. Fuck. I'm still not entirely sure that I have a... that I have a working system with the indices, I guess. Their functions are so long. There's no point in splitting it up into different functions because everything is just called once. I guess it's getting this face and then it's cutting across while ignoring what is underneath it. That's why I think you totally have to cut it at the using the bisector. Yeah, I don't know. But this isn't working. I don't know. Maybe I need to look up how to do it. Maybe this is like let's actually like take a look at what the printout is here. Because I think what this is doing is it's not actually doing what we want it to do. Actually, I think it might be. Yeah, this might actually be doing what we want it to, because this that kind of makes sense. That kind of makes sense, yeah. But then why isn't it cutting how I want it to? To use the point on the plane, I guess lowest D isn't really, might not be the best thing. Yeah, I don't know. I mean, I think that the vector is perpendicular. It just really likes connecting these 2 points, for example, and those 2 points. It just really likes to do that. Yeah, instead of relying on split, I think that we should just straight up do this. We should just do this, yeah. We do need to make sure that these things get cleaned up, though. Yeah, this is the problem about doing this down here. Hold on. You can just do this. Just do this. See, logic, like the logic for that doesn't really make sense in my head. Maybe there was a reason it doesn't make sense in my head, because obviously it doesn't fucking work. Oh. Yeah, never mind. This is fucking stupid. What I'm doing here is fucking stupid. I mean, maybe there's some merit to having these, but both of these counts have to be be greater than 0 for it to work. Obviously. Can you fuck off, please? Obviously. Are normals just 0 all the time? Yeah. Maybe stuck in an infinite loop now. Yeah. Alright, maybe we handle that edge case. Okay, well, never mind. This is with a max depth of 20, by the way. That is. It's just okay. Oh man, that's with a max depth of 20, really? Did I make an infinite loop somehow? How is there an infinite loop? It just returns. Oh, right. I didn't put break here. That's why. That's why I didn't put break. I don't think that we need 20 recursions though. Yeah, depth 20 is fucking stupid for sure. Yeah, depth 20 is really fucking dumb. Yeah, maybe this edge case was just me being dumb and not having break there. Yeah, I don't know. It's still the same fucking shit. I don't know. Like technically, like I don't know. I should be seeing some difference based on like the work that I've done so far with it, but I just don't really see a big difference happening, to be honest. I honestly like it almost feels like if I just like I don't know, just instead of had this perp, what if I just do just like you know a straight up vector? Like I don't know anymore, but like That's fucking funny. You gotta admit that that's fucking funny. Yeah, that didn't work. That didn't work, obviously. What if I just cross an up vector with it? I'm at that point where I'm just like, what if I just cross an up vector with our fucking normal? Like, is that stupid? Yeah, it seems kind of stupid. Not gonna lie. Maybe I shouldn't be going by lowest D. Maybe I should go by lowest D. Maybe I need the it's saying to cross the vectors of the edges. And that's what I mean, I'm doing the vectors of the faces, but maybe I need to subtract the points themselves. But then I mean you would just that wouldn't really give you anything. Yeah, I think that this is how you're supposed to do it, but it's not. Maybe you need a. Maybe I need to visualize it. I don't know. This definitely isn't working. Let me just hard code something real quick. Um. Okay. Now I introduce another set of issues. Let me see 1 to 0. I mean, none of this is what you really want, but... Oh yeah, I need to stop setting P to that if I'm going to try this out. Oh, come on. Oh my fucking god, dude. I don't think that extra depth is going to really help us, but... Yeah. Extra depth really doesn't do anything. See, like, that doesn't make any sense, man. Yeah, I think just take this away while we work on this. Because that extra check is not useful right now. If I'm trying to kind of like hard code things. Yeah, what I really could do is I could just like literally take the normal and then just set the Z component to 1. No, yeah, it doesn't work really. Oh my fucking god. Well, now that line is gone, I mean, obviously everything else is completely fucked. But yeah, that's what I was wondering, like, if I just got rid of these holes, would something else change? So I think maybe I'm not crazy on that. But I don't think that this is the way. I don't think that that's the way. Yeah, I don't know. Maybe I need to do some more research on this, because this is not working out for me. It's so crazy that if you don't get rid of the duplicate points, then everything just breaks. I don't really know why that is, to be honest. Because we had it working earlier. I have an idea. I kind of want to just like pass a array of faces that we have split on before. Similar to my idea before with the current split face. I have a feeling that we are splitting on the same face again and again and again. Maybe. But I don't know. But then I'd have to make a struct and all that. And yeah, I'm probably just gonna head off right now. I can't figure it out. I don't know. I think I might just have to do a bunch more research. I mean, I've like kind of tried to brute force it today, like so much, and it just is different different versions of the same thing. Like, we just don't split this hole down the middle because we've split it across the top instead. See what I mean? We split across the top, and so now there's just this hole on the top instead of in the middle. So they were not fucking around when they told me that this whole decomposition thing was seriously difficult. So I think I might have to look at like a proper algorithm, like whatever I was coming across earlier. I just thought like, okay, this doesn't seem that bad. Like, I could probably wing it, but I couldn't. So I think I'm gonna work more on this tonight, but probably off stream. So, all right, peace out.